and then we'll get into some live discussions. We hope that there will be time for questions at the end. We'll kind of see how it goes, because I think we're going to have some pretty interesting things. For me, I am part, as Sean said, of SVH Capital. I'm Karen Traversy. I'm an investment banker and strategic advisor, and I do help companies at that inflection of growth, transaction, and operations, and kind of moving it along. But what I think about a lot is what does take a business to make it worth investing in and to make it grow. So what is the difference of something pretty cool into something that we all can see turn into an everyday existence, or at least in an enterprise level? So those are things I'm really excited about. And with that, we'll start with Shermi. If you want to do an introduction, we'll go down the line.
Good. Well, before I fully get started too, since one of our members, Wendy, was not able to make it, she is running a 102 fever, so please feel free to connect with her after the fact so you can chat with her, but we unfortunately don't have our full panel. But my name is Shermi, so I work here as CEO and co-founder for Circuit Launch, as well as our educational platform called MechLabs. We are also in the middle of growing our capacity into doing more manufacturing and service, a lot of those things as well. We are looking for partners right now. Some of my background right now. So I spent the past 10 years crawling on factory floors, steel factories, aerospace factories, semiconductor, medical, you name it. So I spent about those 10 years designing systems for fully automated systems or semi-automated systems for people to be able to build their products in thousands and hundreds of pieces. So really my goal here is that I'm hoping to grow a lot of our startups under the Circuit Launch umbrella to be able to scale, to be able to deploy worldwide. So I'm really happy to be part of this panel today, sharing with these ladies. So I'm excited to be here.
Great, awesome. Hi everyone, my name is Sabrina, and I'm from Sunstone Venture and Innovation Center. We are an early stage venture fund based in LA, and during the past few years, we've been backed a lot of hardware companies, robotics. They're pretty much like long cycle and capital intensive. So the perspective I'm gonna bring today is more around commercialization and how investors think about that. And super excited to share with everyone here, and looking forward to that.
Hi, I'm Chango, and I'm the founding GP of Exodus Capital. We're an early stage robotics and physical AI fund. So if you believe that you're the founder of the next SpaceX or Anduril, please come talk to me.
Fantastic. I love it. Lots of early stage. So you founders in the audience, you've got your place. So let's start it off with a general question. What milestones, whether you're from an operator, an investor, or other look, is it that you look at that triggers from something cool into something potentially scalable and something that can become commercialized?
I can get us started. So we actually just had a joke yesterday between Alex and I. He was walking around saying, "Hey, I just found this new agentic AI system I really like. It's the best $200 you can spend right now for the rest of the week until the newest best thing is going to come around." I mean, it's really true. Like, things are advancing at such a high speed that, just your technology alone isn't going to carry you there anymore, even if you're working on the most frontier of tech. So really, what we're seeing, and kind of from my experience on working with a lot of companies, some of the best things that people can do to scale into, larger scale companies is we look for standardization. So when the companies are starting to look at standardizing their first bond, when they're starting to look at, putting together their first data sheet for mean time between failure, when they're starting to look at how are we going to standardize our supply chain, that shows us that they're really at a point of actually scaling the business and not just building something that's cool, because there are cool things all around us all the time. I mean, in this space alone, we have 30 plus companies that are always building cool stuff all the time. So the point is that people do need to be able to scale their business past the point of innovation, and they need to start standardized. And my team knows this. I'm huge on standardization. Anything you can standardize means you can copy and paste very easily.
Love that, love that. I'll follow up with a short answer. So from the investor's perspective, we would like to see not only the technical validation, but also the commercial validation. So I think only the technical validation is not enough. Only if the founder can find a repeatable customer, that makes the investor feel more comfortable when trying to invest into whatever stages that is.
Yeah, our fund's thesis is data is not the moat, but deployment is. And so when they have a unit or multiple units in production collecting data, that is going to give them real, tangible deployment data that is novel, that isn't something that they could collect from like a lab environment. So when they share some idiosyncratic insight about what they've learned on the field, that informs how they're going to design their next prototypes. That's the sort of thing that we look for.
That's very interesting. And just so you guys know, I'm going to go off script. I already I knew this would happen. So interestingly, you talk about standardization. You talked about something from outside, like customers. You also looked at, like, what do you hear in the market? Well, scaling robotics is expensive. So, and you're early stage investors, but you still want to be out. So how do they bridge that gap from idea to building to actually even getting to the level where you're willing to invest at those stages and operationally? Because those seem like tough places to go without some money first.
Robotics is really hard because you're building in the physical world. There's a lot of upfront capex that you're going to have to incur. So then you have a cold start problem, and so we look at that as a moat. If you're able to get out of that cold start death spiral and somehow get some traction, then that's a really solid signal. And usually, founders have some kind of unfair advantage. For example, if you're a large format 3D printing company, and I'm using this as a real world example, a company called Hattie. The founder had built multiple startups before, had built these relationships with vendors before, and so he was able to acquire basically this hardware that he needed for 3D printing without and borrow it, basically lease it for free, and he could pay it off based on the future revenue that he was going to generate. And then basically, because he had this relationship with the company that provides 3D printers, was able to jigger with the firmware and build really customized hardware for their purposes. So we look for that sort of unfair advantage.
Yeah, I think pretty agree with that. And I think for the hardware or robotics investing, it's naturally a long cycle game instead of software or like other areas like consumer. But for investors, we would like to see the companies solving a single, maybe de-risk one of the biggest risks at one round. Maybe early stage might be the technical validation, and later on might be consumer validation. Later on, you can figure out how to scale that. It doesn't matter; it takes a long time. But founders should put more focus on just solving one of the biggest risks at a certain point.
That's interesting. Anything on that?
Oh, I agree. I think because we do see a lot of different startups that goes anywhere between pre-seed to A. They are at different stages, focused on different things. So kind of to Sabrina's point, at different stages, you should be focused on very different things. So then, like, as long as they're highly honed in on what they should be doing per stage, I think to us that's a really great sign as well.
Excellent. Awesome. All right, well, let's keep that going. What is that you often see as the big point of stall, right? When these companies are going, yeah, right? There's a lot of them that they just get to the death spiral or whatever you want to call it, that's the stall. So where are you seeing that, and what can founders or companies do to get around that or get bypass that? And some of it might be mental. I don't know.
I mean, I'll let Jingle and Sabrina chime in on the investor side. So on my side, I'm chuckling because I've done a lot of different system deployments in the past. So I've done deployments anywhere between your small desktop systems all the way to like an entire plan of automation for packaging plants to implement their first automation ever. So I would say there are a couple of things that we're seeing as, I feel like there's a lot of like feedback when I'm talking. So there's a bit of an echo, it's really messing with me. So there's a few things. On one side, yeah, so on one side of it, oh, that's so much better. I'm going to turn this one off. So on one side, I would say 90% of the time, your tech is what's carrying you forward, but what's really stalling you is the unsexy parts. So parts that are like cabling, parts that are mechanical failures, parts that are like single sourcing your materials and basically getting yourself locked into your bottleneck. And say, if a company that you were working with ceased to exist, and now you've locked yourself into a bottleneck and it's really difficult to kind of pit yourself out of it. So I would definitely say a lot of those stalls comes from not necessarily just on the tech side, because a lot of people, and we're in one of the smartest areas in the whole world. So I think a lot of people are able to solve out of those technical issues that, your physics, your, getting your tech to actually work, but it's really the mechanical issues that stalls people most of the time. And the other side that we're seeing when it comes to I would say both traditional automation systems as well as newer systems is companies are not considering how the robot is going to be interfacing with the rest of the workflow. So there's a really big piece in terms of how the robot is going to be working alone versus how it's working with the rest of the world and the factory floor around them. So when I did one of the packaging plans, they actually had us do a really great exercise. Fortunately, it was in the middle of summer in Texas, and where the temperature and the humidity was both hitting about 100 degrees and 100% humidity there. It was insane. But they had us do this process called people and process, the 2P. We actually took blue tape all around the facility and took hardware, basically cardboard boxes, and set up a physical, almost imagine you're building a blanket fort, but with cardboard boxes. So we're actually setting up how big the machines are roughly going to look like, and we have operators just interfacing with the machines and actually seeing how big everything is actually going to be with their day-to-day jobs. And then they get to see is this really going to get in the way? Because you can do all the simulations you want, but someone's going to hit their elbow on something. So they basically proved to us that before we even lay down anything on the functional design document, there is actually proof. One, we're actually solving a problem. We're taking people out of these environments where it's just insane to work in. And secondly, we are also working that into their workflow so that we know this is actually going to work together instead of just saying the robot working standalone. So,
as a quick question before you go on, are they developing the workflow to meet the robotics, or is the robotics being built to match the existing workflow?
There's a lot of bottlenecks with the existing workflow. So in order to add in the robots, it's not just basically pop in the robot and it'll take care of itself. Because once you do add in something that's a little more efficient, you'll start noticing all the bottlenecks around the rest of the supply chain, the rest of the line. So then it was very a concurrent effort. So it was both us developing the functional design document to be able to go to the next step, and on the other side of it, the people's workflow also now has to change to adapt to it. But fortunately for them, it's actually an easier workflow to go into versus something they have to start from scratch. So.
Awesome. Thank you.
Great. That exactly was what I want to share is so I think that a lot of funders have underestimated how important the demand is. Sometimes you build a technology just for fun initially, but it's hard to find a pilot program just because there's no demand on that. But you cannot realize it when you just purely dive deep into the technologies, the details, everything around that. So I think technology should be served for a certain problem that already exists. Do not create a problem or demand from nowhere, and that's the most important reason I think why the pilot doesn't work sometimes.
So we invest at a stage that's much.
Unless you want an echo, you might want to use it.
Just take that one.
There you go.
Yeah, that's the echo.
We invest at a stage that's much later than what you guys have enumerated. So we technical prowess is table stakes, and so for us, we don't see any teams running into those issues, and if they do run into those issues, it's not something unsolvable for them. Where we do see, within our portfolio, I don't want to call them the losers, but the ones that are struggling right now are the ones that haven't raised enough capital. So it's a race against running out of runway with getting commercial traction. For example, in ag tech, we have a couple of robotics deals, or robotic startups, and they're a great technical team, Stanford engineering, so on and so forth, highly qualified, but they didn't raise enough money. And with the industry that they're in, because the margins are so low for big ag, they, a lot like Grimway Farms or Driscoll, they don't want to pay for pilots up front. So they're going to lever as much as they can with what they've got. And so they want to say, hey, you're going to do this pilot for us for free. We're going to barely pay for this. And meanwhile, if you didn't account for the tariffs, for example, you're going to be at negative gross margins just to do a free pilot. And so, that's one of those things. And if they were trying to get to the next round, they have to prove this pilot. But if you're running out of money during this pilot, then you're kind of shit out of luck. So that's what we're seeing.
That's super interesting. So question on that is, if we're talking about, you said the runway and the next level of capital, what is it you're looking, so operationally or as an investor, to help stage sort of the capital outlay or the investment ask and the milestones that you either look to? You mentioned some of them as an investor, or how do you help those companies get to each of them so that they're doing it in a staged approach that actually is sustainable to get them all the way to the end, right?
Yeah, we'll help them with bridge rounds, getting more venture capital in, or potentially debt financing, give them competitive interest rates for the hardware that they collateralize with, potentially. Yeah.
What about either?
I think I would also like to mention the public sector is also important, because sometimes the city government or even the federal government have several projects where like grants provided for specific sectors, and funders may sometimes not be aware of that. So sometimes we will help the funders get involved into the program that will help them to get either the order or like the grant or whatever the loan is to get the funding supporting or operation side. To help them.
Makes sense. Well, on my side, we don't invest, so
you don't invest, but you have to help
correct.
them manage the
Exactly.
money and the timing.
I think for us, it's more of reminding people of managing your expectations. Same thing as things you should be doing at what stage of your startup, and also once you're past your prototype phase, once you're past your pilot, are you making something that's manufacturable? Are you designing for something that can be assembled at a later stage? And essentially, is this going to scale past your first 20 units? So that's some of the things we help people to remind, and we'll provide them with the infrastructure to be able to do that. So I think that's also really important for people to realize, it's not just about building the next best tech that is going to be coming out in the next week or so, and then it's also how are you going to grow past that in the next years to follow. So.
Nice, good. All right, well, so talking about the thing that changes in the next week, let's talk about AI and robotics. So when you look at that, how is that impacting your view on whether it's an investable component, how it's doing in the build? What is that happening fundamentally right now within the robotics world as those collide, I guess, or are leveraged?
I think it's very much a leverage. I think the hybrid model right now with the traditional tech versus how people are applying physical AI is a huge advancement to how automation is done, how robotics is done. Because traditionally when let's take the same example of packaging or logistics, let's say material handling. So for actually a raise of hand, how many people here has actually worked in, I guess, industrial automation or tech or familiar with the hardware process? Okay, so a handful of you guys are. You guys probably are familiar with the context of when a system integrator puts together a proposal, you're essentially putting together a proposal to say this is what this system is going to do. And when you sell this entire system to that end user, you're expected to deliver something that is going to work right out the box. doesn't always work that way. Basically, there are clarifications in there to say, hey, by the way, this system is going to be able to pick up this water bottle really well, and it's designed to do that. And we're going to teach you how to do the rest of them. And that's how traditional tech and traditional automation has always done. But on the flip side of it, it's deterministic. So industrial automation has done a really good job on making sure a lot of systems are deterministic, meaning what you're telling it to do is going to get there at the time doing exactly what you tell it to do. So I would say with the advancement of physical AI, you now can iterate a lot faster instead of just only building your programmed recipes into the system. You can leverage what's available out there to be able to make that system run the way it should right out the box, and it can handle a lot more variations in there. You can essentially reach what's called like one lot size one, so you don't have to have this large quantities that you're actually building in order to make automation work. On the other side, if you're able to leverage industrial tech and also industrial automation or things that have existed in manufacturing for a long time, then you have the best of both worlds. You're able to leverage the deterministicness of industrial automation. You're also able to iterate really fast with physical AI. So that's from the, I would say, from the operating and also just the tech perspective.
Yeah, that's pretty impressive. And what I want to share is like we feel like AI helps a lot during the in the robotics area. With the large language models, there's more ability for robotics to do different tasks for human. But again, we wanna see some product that really helps people to solve the problem. Maybe bring more autonomy, solve more issues in the day life, or like either in the industrial side to increase the efficiency, and do not just bring something that out of the demand. Like no demand on that, okay. So that's the concern from us. Yeah.
I won't share an opinion, but more an observation about why this is true. AI is the unlock for robotics. So we had first wave of robotics come around 10 years ago with fully self-driving cars and the boom of the physics sims. And then that collapsed. And then now we're seeing a second wave of robotics come to fruition, which is why there's so much interest in the humanoids and the foundation models and world model space. And that's because there's this technological unlock. There's this inflection point that is enabling robotics to be smart for the first time ever, rather than these like dumb hand-coded manual robots. So that's the reason why it's unlocking so much venture capital and so much innovation in this entire sector. So we're in a boom right now, and then again, I perceive there will be a collapse and then another boom.
All right, so let's talk about security on AI, right? If that is the big conversation outside of this room, right? Where everyone's nervous, worried, what's real, what's not. How do innovators who are using it in a robotics standpoint, what do they have to be aware of? And if you're looking at from investment or building, like what is it we're concerned about in terms of that security, cybersecurity, and all of the other, or the missteps that AI is still doing, those kinds of things? How do you build that into the risking or the de-risking of your build or your investment?
I don't have too much of a view on cybersecurity just yet. I think that's a little bit, it's a little bit early to be thinking about that. Our view is that a lot of robotics, like humanoids specifically, are going to be operating on the edge. Mm-hmm. And there's a lot of, crypto protocols that want to build in payment systems like directly into the robot for, this idea of being able to like send your humanoid to go shopping for you or something like that. And then, if it gets hacked, if like somebody steals your robot, and then it could like steal your money or something like that. But that, that's I don't think that's like anywhere near, like not in like the next 15 years. So I'm not really concerned about that.
Yeah, pretty much same for me, because we are dealing with the founders super early stage, like seed run, pre-seed run, and they are mostly struggling with the technical validation and maybe early stage pilot consumer validation. So, but from my perspective, I think founders should be thinking about ahead instead of solve the problem until it appears. Yeah. So they should be concerned about the compliance, regulatory things, everything before you're ready to scale that.
I'm still stuck on the sending your humanoid to the grocery store thing. I wonder if you can teach it or like have a node to grab from the back of the shelf instead of the front of one. I mean, we've all been taught that, but is the humanoid going to know that? That's the better question. So once we get there, that'd be amazing. Anyways, I get distracted very easily. So on my side, I would say in terms of like cybersecurity, maybe I'm just more of a chaotic person. I think when it comes to a lot of the things that are inherently unsafe, that's how we should be treating AI. Essentially, it is inherently unsafe. There is a lot of things that people need to realize, like it's not built to be safe yet. I mean, I know there's a lot of efforts being put into that right now to make it safer for people to use. However, I don't think that should be a stop for people to, just basically like, oh, I'm going to back away from this because I know it might be unsafe. But I think this is why when you're building the companies, to Sabrina's point, once you get to the point that you actually need to do that, you need to know what guardrails to put in place. And I'm double making this. So you just basically need to know what guardrails you need to put in place and keep yourself educated and make sure when you're building this, it's not to shy away from it, but to actually say like, hey, I now need to have my team be educated and build the guardrails to make it safe for what I'm using it to do. And still do your due diligence and still do your, due process to be able to make sure it's safe for your usage. Because for example, like if my robot is going to the grocery store to make sure it actually grabs from the back of the shelf, I don't really care if it interacts with what's seen at home, really. Like, so I feel like there's a lot of different things that people may be overcomplicating it, but just set your guardrails correctly, I think, is the way to go.
Oh, perfect. All right, let's take a little bit further look now at globalization, right? We all know a lot of manufacturing is happening, especially in this arena in China. I think I read a statistic. I was telling someone, I learned this statistic, 75% if you take Asia in total in 2024. So, and the U.S. is a lot of innovation and research. One, do you see those statistics playing out? And two, so if you're looking at these companies, how do they set up for scaling and utilizing what's necessary in terms of geography and not becoming overly dependent? You mentioned the tariffs, those things. So what does that package start to look like when a company is really building, and who do they need to leverage given where the expertise may lie in one arena or the other?
Yeah. With the FCC regulation coming down, I think North America is really attempting to drive towards reindustrialization. But of course, you can't really have an edge in the hardware space without depending on the Chinese supply chain, no matter what, right now. That being said, there are allied nations like South Korea that a lot of our portfolio companies use to source components. Toyota Research Institute buys humanoids from Rainbow Robotics, another South Korean company. Same with Persona AI. They source custom parts from South Korea. So having these alternatives is really beneficial. And we're constantly creating partnerships with other countries like European part providers. So that being said, I think if we're talking about components, the companies that are developing their own in-house is really powerful because that gives them an edge over other companies. What happened with BYD. BYD had a components play that was around battery cells, and that gave them an edge over other companies. And same with Unitree. Their thesis was that if we control the actuator, then they control more of an edge with their humanoid companies. So with the U.S., I think we may be starting to see some of that movement as well, rather than outsourcing these needs to places like China.
Yeah, I think most of us don't want to see the deglobalization trend, but unfortunately that is the trend for now. But from my observation, especially in Southern California, there's a lot of founders or supply chain factory owners from Asia. They're trying to bring their business to America right now. So they're trying to set up branch in the United States, and that also helps them to get a business from here. But as a founder, I think do not just be smart, and you can utilize and leverage the supply chain advantage in Asia, even though you do not allowed to sign a contract directly with the Asian company. But there's a lot of companies setting up the new branch in US, so that's the way you can utilize that.
I think adding to what you two already shared, I would agree that a lot of supply chain does live outside of the U.S. right now. It's undoubtedly true. So, but I would say to complement to a lot of those things, we still are seeing a lot of success for people to build their initial prototypes locally to make sure you're leveraging your local resources until you're ready to actually scale outside of that. And then the question to really consider here then is once you are considering globalization, you need to figure out how much control you're still going to be having of your supply chain and your design, and how much you actually want to give away for your time to market. So that's basically the trade-off you're essentially looking at here is if you're really trying to get to market as quickly as possible, you end up losing some of the control of your tech side. So I mean that's true no matter where you're going. And then on the last side, one of the things that I don't think has been mentioned yet is once you are getting ready to deploy, do you have your service partners ready to deploy with you if you're globalizing outside of just supply chain? But once your tech is ready to go global, do you have service partners, basically 20 miles within where the systems are going to be set up? And because a lot of the failures that we're also seeing is people stretch themselves really thin by deploying their first system just on the other side of the ocean. So then at that point, are you still focusing on your core business, or are you just your own service team? So I think some of those things also need to be considered when you're considering globalization on both supply chain and growing your company globally.
So in terms of, so that's on the build and pushing out, who's the buyer right now? Who's really the buyer? Where are you seeing that more? And in the strategies that you're looking for, knowing the markets that are really leveraging robotics and leveraging this, where do you want to, even if you're not seeing it, where do you want to see that go, if that makes sense?
Factories.
Well,
oh my God. I think anywhere. I mean, just kind of like what I've shared already. In the factory setting, so much of automation is done in a very traditional industrial automation way. And I think by implementing like humanoids or by implementing ones that are on wheels, it's a really great play if they're able to integrate with the existing workflows, if they're able to play into the existing like factory automation softwares, and then they can pull the data together. And I know Shango earlier kind of shared like, data is no longer your mode, but on the flip side of it, if you are able to leverage existing factory data into building your robotic systems, I think that is also a huge advantage right now. So where I'm hoping to see is that, in the next year, no one's out there taping things onto the floor in the middle of summer, and you have humanoids doing a lot of those things. I think that would be very exciting.
Yeah, for me, I'd like to see for those traditional industries, maybe commercial real estate, maybe restaurant, maybe some big companies like the car company. Maybe I think there's a huge potential of them to adopt these new technologies or new robotics trend to do some innovation in their internally product or like the workflow. So I think there's a huge potential on that.
Yeah, I'm strictly going off of the data. Last year, 2025, Unitree shipped 5,600 robots. And they're by far the leader in humanoid sales. So they shipped almost all of them to researchers, like robotic researchers. So it's still very early in the space where we don't see product market fit for humanoid robots outside of that territory, and even with one of our portfolio companies, these like Feather Robotics, they deployed to other B2B companies that may want to buy these off the shelf for their own purposes. So we're not actually seeing these robots hit the application layer just yet, unless they're a very highly purpose-built application-specific robot, like for ad tech, for example. Yeah.
Okay. Well, so we've been given the sign. We're going to open up for questions in just 1 minute, but I have one last then. What if, for you all, before we go into questions, your last takeaway that you would want everyone to think about or know about from a robotics perspective in your world?
I one point from the previous question. So I think government is also important in potential buyer of the robotics product. So I think both the U.S. government and also the other countries' government is putting a lot of budget around this, either around defense or other areas. So I think that's my takeaway for this. So do not underestimate the commercialization, and also try to leverage what you can utilize from the government resources.
Yeah, I would certainly agree with that. Government's going to be the biggest buyer, especially during recession. If there's no other buyers there, and if there is a global conflict, government is going to still be the one dishing out the money, propping up the economy. So yeah, we're definitely looking at companies that are dual use within defense, maritime. The picks and shovels that go into there. So we've deployed capital to a couple of space-related companies, a couple, Persona AI's picks and shovels. They build ships, which obviously has segues into maritime defense. And then, again, like 3D printing companies that print large format parts for boats, for like Blue Ops, these defense companies, for example, or like Anduril, drone parts. Basically manufacturing these parts very, very cheaply, very, very quickly. That allows them to scale these and domestically ship to the U.S. Even quicker than if they were to depend on China. So.
I'll share from my perspective then. So I would say from the operator side and from seeing a lot of these hardware startups, my takeaway is basically if you think you're 95% of the way done because you solved 95% of the problem that you're trying to solve, you're wrong. So really 80% of your time is going to be going towards that last 5%. So for the love of God, please do not save your cabling harness for the last thing. Please don't go for it saying like, I'm going to single source this is going to solve itself. It's that last 5% that's really going to take your 80% of the effort. And we're seeing that day in and day out, and we're seeing these Frankenstein systems that are just adapters and adapters and adapters. And they're really, really difficult to maintain, really difficult to scale, really difficult to deploy. So really think about those things, really shift those last 5% into something you're thinking about on the regular as well when you're building a system.
Thank you. Fantastic. All good takeaways. Can we do one?
Yeah, one question. I'm going to be the mic runner.
Yeah,
oh,
perfect.
Someone's ready to go. Before that, actually, a quick announcement. If anybody is parked next door, right, at Kupang, they might tow your vehicle. So anybody that's parked, which is right on the right-hand side, right, Kupang? Show me? Yeah, next door?
Kupang, yeah.
Kupang, yeah. So make sure to double-check your car if you're parked next door. Sorry about that.
With regard to humanoid robotics in particular, do you see a market opportunity for robotics in high-mix manufacturing?
Absolutely. I think because of the advancement of like your vision models nowadays, that is highly feasible to have a high mix, low volume system being rolled out. Because in the past, I think the only way to really justify an automated system or a robotic system is by having a low mix, high volume. I don't think that's true anymore. Because you are able to do a lot of these kind of calculations on the back end, and you can do that on a deployed system very easily. I think the high mix is no longer just like, a myth that people can have. I mean, just look at some of the logistics companies and a lot of the physical AI logistics companies. They're able to kind of pick out things real time. You no longer need to program in your recipes to be able to know what you're actually picking up. Because I still remember the days you have to analyze the CAD drawings to make sure you know where the pick points are going to be. You go for the easiest part or the hardest part to make sure you have a good reference point of where you're building. But I don't think that's true anymore. I think now a lot of those things can be done on the fly. And if you can really hybrid that into existing industrial tech, even better. I think it's very, very feasible.
I have a follow-up for that real quickly. Not for humanoid, but for robotics and AI in general, which is, I've spent the last 6 years fighting the fight of trying to ramp to MP for
Okay.
a very low margin component that you have to manufacture incredibly high volumes.
Yeah.
And the manufacturing, of course, has to be deterministic. You just couldn't use AI.
Yes.
But on the QA/QC side, I think there's a lot of opportunity for AI there, but the problem is it's too slow, especially for vision analysis. How do we turn that into something that's less arduous so that QA and QC could be a highly automated, non-deterministic?
So some of the issues we ran into a lot with QA/QC in the past is people are not setting up the correct criterias, and they're not like finite enough for the QA/QC system to actually work to the level you want it to be. But now I think with leveraging AI, you can now set rules around it of how you actually want the QA/QC to be done. What are some of the criterias you're looking for, and then essentially have the AI iterate from there. So I think that should speed up the process that solves the biggest problem under QA/QC that hasn't been solved before. So I would say to kind of your question, it's twofold. Like, so you one side of it, you need to know what you're looking for. So when it comes to QA/QC, you need to understand like exactly what you're looking for. So take painting for example. So if on a surface you want to look for any blotches that's bigger than this hole on a square inch setup for every square inch, then you need to figure out how you're iterating, how you're defining that, and then past that, then essentially like once you're going past that, then you should tell your AI of like, this is what I want you to be looking for, and essentially help me think about other things you also need to be thinking about that you now don't need to hard code it in. So now you can have your system think on its own to be able to do that. Yeah.
We have time for one
more
question.
Hi, I'm coming from a marketing perspective, so I apologize if this is like a stupid question. But earlier you mentioned that like with robotics being a hardware problem, it does take a long time for any investment to see any return. I'm curious to know, like on the software or community front, do you see that more like as a mode? For example, if people are building, let's say, like a robotics OS that everyone can use to make one specific robot do something like reach into the back of the, what was the example you mentioned? Reach into the back of the grocery store to pick up like specific items. If there was like a software side of this or a community side of this, is that a good mode, or is that like a?
Oh, absolutely. I absolutely. We got like Thomas over here is like mouthing that as well. You're basically talking about robot operating system. So that does exist, and a lot of people build on top of it. And outside of that, like even on the automation side, on the tech side, there's a lot of kind of open protocols that people are now leveraging, because now you basically have thousands of other coworkers also contributing towards the same system that you could be building on to make sure your time to market is a lot faster and is proven to be a lot more successful because other people are building on it. And on the community side too, I mean, I see one of our founders poking his head in back there. A lot of our hardware founders are like 1 to 2 people companies. What that means is also like when they're here at the facility, I see them spending time in each other's cubicles all the time. So they're essentially almost co-workers for each other when they're developing in the robotics setup. And it's really cool to see, because they're now like, they have a built-in set of co-workers that are all working towards different goals, but similar mission. So, I mean, I think the standardization and also just having a community, having like a standardized software side, that's a huge piece for building hardware and having a moat for that.
For us right now, I'm talking about present day, and I may be completely wrong 10 years from now after we have these robots ubiquitously like out in the wild. It is not enough of a moat, just if it's purely software. For us, hardware gets commoditized no matter what. You're seeing the price of the humanoid robots from Unitree go down from $84K from 2024 to like $24K now. And so we see the hardware as the foot in the door that gets the company to then integrate directly with the customer workflow. Once their software is directly integrated, then they have vendor lock-in if the customer itself continuously relies on the software. But
for us, it doesn't make sense if they go in with the software first and then something later. There's no lock-in.
So basically, you guys are unsure whether to go iPhone or Android yet.
Right, or rather like the OS doesn't even exist yet because the libraries, it's like get the phones into the hands of the people first. I don't care what phones, but there's not even an OS there's not even like an app store to speak of. But once the phones are in their hands, everyone's hands, there's an app store, then we can talk.
Yeah, I think it's highly depends on the market, how competitive the market is. For example, like the iPhone and Android market is pretty competitive. There's two big giants in the industry. But for the other industries, for example, we invested into a Boom Supersonic. They're building a aircraft, but that one is not as competitive and as mature as the other industry is. So they're building the product for so long, and they do the test a lot. They do the live stream every time they do the test. That somehow builds up the moat, given there's no a lot of competitors in that industry. So people get more confidence when they see the test is successful.
Fantastic. Thank you all very much. I want to thank our panel. They did an amazing job.
Let's give a round of applause. But what I'm going to do is I'm going to get the photo of the panelists with the audience. If you're going to stand right here, I'm going to take a photo of you guys in the front. And we're going to have founder spotlight while I get the photo. Just stand right here. Okay. Everybody, if you want to be in the photo, wave your hands. All right, this is a beautiful photo. All right, 1, 2, 3. There you go. I got everybody. Great job. Thank you, everyone. Again, reminder, if you park next door at Coupang, right, make sure you move your car. And we're going to check the AC system to make it cooler here. All right. So with that, I want to introduce Syncritic, the Agentic Venture. So Syncritic. So I'm going to hand the mic over.
You want to start? Or?
Yeah, you ready to go?
All right. Hi, everyone. My name is Akash Suraf. I'm a founder of 2 AI companies. One is called the Agentic Ventures and one is called Sanskritic. Now, you might be thinking this is going to be 15 minutes of boredom while I speak. I promise to keep only one slide about what I do and actually talk about 2 very interesting concepts. One is a concept called, I'm the agentic AI space, and normally people ask questions, what's next after agentic AI? And the most obvious answer is, of course, physical AI, robotics, embodied AI. But we think that there's an interesting new space coming up, which we call decision twins and AI neo-factories, not neo-labs. You have all heard of AI neo-labs, but we think there's an interesting new space coming up called AI neo-factories, which I'm going to speak about. So, quick introduction to ourselves. I run 2 AI companies. One is called the Agentic Ventures, where we worked with more than 110 founders to incubate their startups. And as of today, 70 of them have a live product. Many of them have raised money and seen a lot of success. We're kind of we're more like an engineering incubator, where we don't provide office space. We actually work with domain experts to build their AI products at our own risk, help them take it to market, and they only pay us once they're able to successfully fundraise, and we don't take any equity, right? Also, interestingly, we worked on this new generation reasoning technology. Again, I won't spend much time on it. It's a new generation reasoning technology. We call it a post-LLM technology for reasoning. It's a meta-reasoner, so it's a reasoner which sits on top of a language model, but it leverages the fact that language models have a lot of information. They can search very well, they understand natural language, but the reasoning itself moves to this newer layer called meta-reasoners, which typically you can train by giving it straight textual feedback. So we use this concept, we use 2 concepts here, meta-reasoning and recursive self-improvement, where you essentially use constantly self-improving AI in the process of running massive scale simulations as a way to build new reasoning engines, which we have seen for many cases actually work much better than how large language models reason. So that's a technology that we recently announced. And this is why we built our new. Most of the agentic AI or AI focus on what we call the automation problem. We are trying to automate work what human beings. A voice agent which can replace a receptionist at a dental office. Typically what we call automation problems. Probably a bigger opportunity the way we see it, and of course we worked on more than 110 of them, so I'm not saying that these are bad ideas, these are very, very good ideas, right? But there's an interesting new opportunity which is coming up, which is what's called amplification, which means there's going to be a lot more advanced AI which will augment humans, right? Think of it this way. A senior lawyer who works with his juniors and works with the interns doesn't even trust the junior and the interns completely, right? Forget about trusting an AI, right? And in this scenario, what you need is a different style of AI, where reasoning is not a byproduct to get to a correct answer. Reasoning is the product itself. Why? Because what, as an expert, you want to do is run multiple scenarios in your mind, right? Analyze different perspectives, and then come to a conclusion, right? In this case, you could be a manufacturing guy running some. That's what basically we're saying, that maybe the next big opportunity is on automation. And before we get to physical AI, but there will be an opportunity in between. What we call decision twins. So what a decision twin, and the numbers change immediately, right? What if since we're talking here about robotics, example I'm going to bring up very quickly. In this case, the use case here is there is a 90-degree angles, and the vendor has come up with a software whether it is safe enough to do it, and two is basically, are you going to be in compliance with all the safety, angle of the robot, factory warehouse layout, what time do workers show up, near miss data. Now, obviously, it's a multivariate problem. This is not an automation problem. Using here fundamentally is the fact that you can almost analyze this particular problem, and what we're going to do is take the question, reasoning and simulations which go on for days, they actually they run more simulations to come back and say that, look, your baseline, this is your near miss. After you make this update, what's going to be the safety and near miss, and how much you need to reduce your speed by in order to still maintain the same safety levels you had before this particular update. This is not a kind of glamorous problem of building robots, but it is a very important problem when you start deploying scenarios at a massive scale. If you're familiar with the term counterfactual simulations, where you fundamentally ask the AI to branch off the reasoning, you're able to analyze all these perspectives. As we say that in humans we have great intuition. We can sense, but we can't. That gets very interesting. So an example could be, you're building robots and you need to do a verification validation program. You need to build a test plan, right? Now, here's the problem. If I look at all the combinations, it leads to almost 400,000 different test combinations. All what we call decision twins or reasoning decisions twin come into play. Another, you've been tasked to find a way to reduce the cost by $10,000, but you have constraints. You have to meet certain safety standards, certain quality standards, certain battery life standards. Now, how do you optimize in this particular case is what we call a decision twin, right? And the way we see this is that the value that decision twins provide as compared to classical agentic automation. In an agentic automation, you're replacing a human being, right? Most likely. So what happens is, if a human being costs $40,000 a year, maybe you can charge $5,000 or $10,000 for that agentic solution. With decision twins, what you're really doing is the three scenarios. One is you're basically empowering experts who are very difficult to find, right? Like we applied this for a pharmacovigilance use case where it cuts down the time to figure out, to get your, what you call the pre-island, to pay a lot more money for a system like a decision twin. Twins is you can't write code just using Claude code, and neither is this AI, which is very advanced, and also need a lot of domain expertise to build these decision twin systems. Neolabs means, if you're ex-Google, DeepMind, quit your, or Anthropic or OpenAI, quit your job, tell a VC that basically it's basically saying, so I'll give an example of a new factory. That's the best way to explain it. So we're working with this insurtech startup in San Francisco, and they're trying to basically build AI agents, insurance for AI agents. Insurance works on the fact that you have past data on fire, property, casualty damage, based on which you can make your underwriting models, your, clauses in your coverage, all work on past data. With AI agents, there is no past data. With robotics, there is even lesser past data. How do you go about building this? So the technique we use, we actually applied this technique to build our reasoning model. We actually used our reasoning model where we didn't have data sets. We had to pretty much build data sets synthetically. So we use this technique called recursive self-improving AI, along with massive scale simulations with what's called sparse human feedback, right? So think of it this way. You literally start off by going first principles. So if you're looking at building a manufacturing in your factory, you're starting off by scraping information, scientific information, patent information, component specs. You build an ontology on top of this, explaining how these things link to each other. You build an agentic reasoning core, and then you launch massive scale simulations. And you may run 1,000, 2,000, 10,000 as number of simulations trying to get closer to what that new factory looks like. And that means your active experimentation, your physical experiment AI. But what AI is doing is it's making this easier, because AI, besides numerical data, can also look at textual information, entire operating strategies. Like an example could be, let's say, if solid-state batteries come in, how do you help them cut that time to make, it's a highly multivariate problem. You have safety problems, material defect problems, servicing problems. How do you sit and model that is a very, very hard problem, and that's where what neo-factories do. They try to model the real world to the maximum they can in the virtual space before you have to actually go to the experimentation space. And the nice part is, people who work on neo-factories get the benefit of what's a flywheel effect. The more and more you work on this, the more your data becomes better. And this is maybe a new form of what people call digital twins will be. So my last slide is, we're looking to, of course, work with founders, leverage your knowledge, and jointly build a product, either as a, this is my colleague Nicole. Nicole, could you stand up and just, so she's around. That's her email. If you're interested to talk to us about this, please drop us an email, or we're around to speak to you. Thank you so much.
Thank you, Akash. Critic, thank you so much. And again, reminder, there are tables outside. Great team members, amazing. They're also helping with some of the photography and just great person sponsoring and hosting the event. Thank you so much. All right, next up we have Michael.
Am I good to go? Yep. Yeah, okay, awesome. Hey everybody, good to see you today. My name is Michael Kelly. I'm the CTO at Labs. We're over in Alameda, California. And I think one of the previous panel members, Ocean Robotics, and I think that's a nice segue today. So for what we do at Dolphin Labs, we're building the infrastructure for persistent ocean robotics. So one of the key problems in the ocean space, and most of you are probably familiar, the ocean is a big, it's a wide and a deep place, right? A lot of volume of water that we need to go investigate, and it's very blind right now. There's a blind surveillance gap in the ocean. We're open to pipeline contamination and damage. We're open to subsea cable damage as well. And right now, there's a lot of impacts on the economics, all kinds of countries, all kinds of coasts, and this is a problem. So what we're building at Dolphin Labs is the X node, and specifically a network of those. So the core of our system is the X node. You can see it in the bottom left, so that's one single unit. It's roughly the size of your dinner table. You can see a person there for scale. And what it is it's a wave-powered autonomous node that provides both power and communication to subsea sensors and subsea robots. And this happens at a power factor that is 10 to 20 times more energy dense than, say, a solar buoy that's out there. So that's why we went for wave energy, because it's more persistent and more energy dense. And just wanted to highlight, so yeah, one single unit is an X node, and then there's multiple of them that we can connect together, which you can kind of see in this image here. Depending on the user input for the mission profile, and also the wave condition to optimize for power generation or communication profile. We'll look inside this a little bit, but this is a hardware product. So a little bit of background how this connects with the other ocean robots in the sea. You can see on the right here, starting with first the collection of data, right? That's the thing that most people are interested in. They want to know what's going on subsea. They want to know, is our pipeline okay? They want to know what is the, they want to gather some new information on mapping on the seafloor. So what it usually starts with is an underwater vehicle. So that's what you can see in the bottom left there. Sometimes we also have subsea sensors that are collecting data. And so that's kind of the first layer is collection. The next one is compute. So we have kind of an open payload bay where you can put whatever type of edge compute you want on board. We have some standard as well. So we do that, all of that compute on board, and that actually lowers the bandwidth for the amount of data we have to communicate back to shore. So that's important because one of the key problems at sea is the bandwidth of communication. And then, yeah, just the last layer or onto your vessel. Yeah, we use standard satellite communication. Right, acoustic is very slow. We're also working with a company on comms, subsea as well. And just looking at the whole kind of ocean robotics, if you're new to the space, the first layer are basically autonomous ships that swim around, control themselves, or that's what a lot of people are interested in, being able to deploy our system. Them, they have a mobile, and we're also the stationary portion. Water for roughly 8 to 24 hours. What we're looking to do when we partner with them is increase their endurance from hours to months, just subsea sensing networks. So what we have in this picture here is so this is down there listening for things like what are the types of marine actors in the area. So we would work with them new types of sensing and also freeze up the bandwidth limitation. So now moving to real photos now. So we've been built off of San Diego for 10 months with a 99. Inside of that system is actually the drivetrain, which is the system that converts the system. So we took this unit, a package that's easier to deploy and more well fit for is at our test facility. What this bench pushing back and forth with regular wave profiles or irregular wave profile, like how much power we generate, what type of depth control we're using. So it's a really great facility we have there. You can see for pressure vessel made for depth because we submerge. You can see this is, I said roughly this out at the table right now. He's on the left. And the other thing I wanted to highlight, our co-founder CEO Raleigh's here. I'm here. Hard today, but we bring backgrounds from the academic side, also pretty diverse team that we have working over there. And so we spun out from Wave, which was producing that X1 system and is looking to scale towards. And we miniaturized their system. This was in 2022 when the company was first formed. And yeah, for our background and funding, it's actually been all non-dilutive so far. So 4.2 million non-dilutive partners here. The Department of Energy, one in our Office of Naval Research, are three of our big ones. And then we have a lot of good partnerships through the NATO Diana network too. And yeah, just looking forward. It's been a great day so far. Met a lot of excited people, and really learning a lot so far. But yeah, just want to say, come build with us. We have new positions launching this fall, and we're also opening a fundraising round in a few weeks. So please come find us at our table. We're just right outside the door. And yeah, looking forward to meeting all of you.
Thank you, Michael. Make sure you come check in with the team. And we have LV coming up next. And while you introduce yourself, I'll get your presentation.
Oh, great. Good afternoon, everyone. I'm LV. I am the CEO and co-founder of Trellis Robotics. So we're building these soft, growing robots to get inside of industrial assets. So it's a lot more helpful with visuals, I promise. Great. Sorry. Yeah, so we're actually based right here in this building. So we have a couple of the glass offices kind of towards the back of the building. Talk a little more about that later, but basically there are these there are assets in high-value industrial facilities, especially the ones dealing with things like chemicals, oil and gas, and nuclear facilities, for example, that are expensive, dangerous, and sometimes even just impossible to get to in the first place. So this is just a really hard place to work in. So a lot of the times getting into these kinds of facilities or getting into these assets often means dealing with rope access for things in elevated places, which is dangerous, or entering things like confined spaces, like tanks or underground structures, just to get around it. So that's even if these kinds of assets could even be accessed with those techniques at all. So roughly 40% of these kinds of places just can't be accessed at all with existing tools. So when that happens, in order to get inside of those places, these companies often have to go in and manually disassemble and reassemble entire assets to perform something as simple as an inspection. So we've gotten a wide variety of numbers, but it can go well into the six-figure range for every instance of every single access or inspection of those types of assets. So here at Trellis, we are developing a novel type of soft robot to get into those spaces that no other tool can get to. So the way it works is you basically take a tube. Could we play these videos? But you basically take a tube of a soft plastic or a fabric, you invert it into itself, and then when you inflate that tube with pressurized air or any other type of fluid, it's able to grow out new material from the tip. So this has a couple of distinct advantages. One of them is the fact that as you're growing through these environments, the outside body doesn't actually move relative to the environment. So all the new material comes out from the tip. And then because you are using pneumatics, you're able to generate some enormous pushing forces from the tip of the robot, which means that you can get much further into these types of hazardous environments than other types of devices. And because it's pneumatic, it's also very soft and compliant. So in that second video right there, this is one of my favorite demonstrations with this type of robot, but we're literally able to grow through a bed of nails without any issues. So that's because the body of the robot doesn't actually move relative to the environment, so you're not able to tear or rip the outside skin as you're growing through these types of like sharp or dangerous places. So our beachhead market focuses on those 40% of assets that can't be accessed with the tools that exist today. So what that means in reality is a lot of these small diameter complex pipe geometries. So things like borescopes, rovers, pigs, or pipe inspection gauges, they basically get stuck where every time they deploy one of the other types of, they need to have like multiple different types on hand just so they can send them in after the ones that get stuck if or when they inevitably do. So this is a very big challenge in those industries, and they're always looking for new solutions to this type of problem. Okay, I think we're missing a slide, but it's fine. It's basically this prototype, but just scaled up. But we basically built a prototype that is able to show our robot growing through a system with multiple tight radius turns, branches, and vertical sections. So it's basically able to, so there's a steering device at the tip that basically allows you to pick through those branches. It's able to grow through these very tight radius turns. And as you can see, those vertical sections basically don't present any sort of challenge to the robot whatsoever, which is very much a rarity because it doesn't matter if there's anything like growths, debris, or cracks on the walls. Because you're a pneumatic structure, so as you're growing up, you basically form your own like support structure as you grow up rather than trying to rely on the walls as supports. So currently, we do have high quality vision at the front of our robot. So this first and foremost lets our operators be able to steer through the pipes as they're going through it. And it also lets them detect things like obstructions, cracks, or pitting that might be on the pipe walls. But I do want to emphasize that we are fundamentally a hardware platform. So we can basically put whatever can fit at the front of the robot and integrate it into the robot. So we're actively working on high quality localization and 3D mapping, like asset scanning, things like that, as well as integrating like advanced non-destructive testing modalities, such as ultrasonic thickness, eddy current, and magnetic flux leakage detection to the inside of the pipe, which to actually, what they're doing right now is basically having to go through sections on the outside of the pipe, which can often be blocked by other types of assets. So going through the inside basically lets operators get these kinds of high quality data without actually needing to like send someone down or repel someone from a rope. So we're conducting pilots with our 4-inch diameter system at the end of this year, and continuing that with our 2-inch diameter system kind of early next year. And that's also when we're planning to raise our seed round. So I'm also really excited to announce that we were recently awarded the NSF SCTR Phase 1 award. So it's non-dilutive funding that goes directly to helping projects like us where it's a novel type of solution for a really big industry problem. So we're a Stanford spin-out. So my co-founder and I have actually been working on this technology for the past 4 years on the academic side. So we're really excited to take all of our hard work and bring it out into the field where it really belongs. So we have both Stanford advisors and the original inventor of the technology who was also our advisor in our undergrads. So yeah, we are hiring right now for full-time mechanical and electrical engineering roles. Find me afterwards or send an email to, or send your resume to my email. I'm always happy to chat about this technology or any other types of robots like this. So thank you.
Thank you, Evie. Make sure you stay in contact with them. All right, next up we have Evan with Quirky AI.
All right. Hello. Oh, good. A little close. I'm Evan Owen. I'm the co-founder of Quirky AI. Other one. Sorry. There we go. Oh, there we go. Co-founder of Quirky. This is how you know we don't have Gen AI yet. It's not AGI yet, because the presentations are always Murphy's Law. I'm Evan Owen. I'm the co-founder of Quirky AI, and over the next few minutes, I want to convince you that the AI models you deploy should learn for you, and today they don't. So everyone in this room is deploying or about to deploy AI agents. Those agents have some key limitations. They don't remember your workflows between sessions. What looks like memory is pattern matching over other people's data, and retrieval papers over the gap without closing it, because intelligence is still fundamentally living in the model someone else owns. So every hour your team spends with a frontier model, the learning compounds for the lab that built it, not for you. Enterprise AI as deployed today does not compound for the enterprise. If you can see, this chart has the current flow for that training. So since this is a robotics and AI training time, composition is what buys you data efficiency, faster reasoning, and generalization. These two stacks are obviously not equivalent. Robotics carries constraints that language models don't, but the principle transfers. The LLM space is still catching up to that lesson. One giant general model for every task is a monolith. The efficient path to general reasoning has the same shape robotics found. Specialized models that each own their own domain deeply composed. This is essentially what Mixture of Experts buys, but only at one layer of the model, and that piece of that composition you own is the model that holds your domain. The industry has always moved in waves and cycles. The last biggest crest was the expert system boom of the 1980s, and those were very specialized systems. When that wave broke, we got the last AI winter, and the climb ran through the deep learning in 2012, foundation models in 2018, and has been generalization all the way up. That wave is apexing, and one big reason is that these labs have largely run through the corpus of high-quality data that fueled the climb. The next high-quality corpus has to come from a massive user base. Your usage becomes training data, and the learning compounds with them. When the market corrects, the upswing in the cycle goes to specialization that you own, because in your domain, the high quality corpus already belongs to you. Yesterday, I heard a group of VCs talking about local AI being the future, and it's the future because you own that domain and can extract all of the value from that domain that you already own. Models should internalize it and keep compounding, and the prime time to position for that is right now. So this is where the industry is going. Open weight models now sit within months of the frontier and are ahead already on several evals at a fraction of the inference cost. Specialization you own is a future that you can bet on. So let's talk a little bit about that deployment posture and what deployment posture you should take and how we get there. It really comes down to 4 very simple steps. You convert the model you already rely on into an architecture sized for how you actually deploy. You deploy it where your data lives inside your boundary and evolve it continuously on that data, on policy, absorbing new work without losing prior capabilities. And you re-migrate when something better ships, so the learning survives the architectural change. Conversion makes deployment affordable, and deployment inside your boundary makes learning on your data compliant. Remigration means you're never behind the frontier. So what previously gave ownership I skipped one more. Sorry about that. What previously gave ownership a high barrier to entry was the KV cache. In a transformer, memory grows with context length and with every concurrent user, so that serving a long context model privately turns into a capital project instead of a deployment. Hybrid transformer SSM architectures change that. They carry the sequence work in recurrent state and keep a small set of attention heads for in-context retrieval. And this is already happening in production, with Jamba, IBM's Granite, and NVIDIA Nematron all shipping this approach. The risk of moving off of pure attention has already been absorbed by others. This room should care more than anyone else because robotics are edge devices, and memory bandwidth is exactly where the edge inference is bound right now. I don't know if you all saw the Boston Dynamics robots outside, but when they lose network connection and they fall stiff, it's because the models can't be deployed at the edge. So this architectural family is what let owned, continuously learning models live on a rack, in an air-gap facility, or on the robot itself. And it means the architecture is something that you match to your context length, your concurrency, and your hardware, rather than just a bottleneck that you have to work around. So this is what Quirky builds. Our pipeline migrates a model you already depend on into a hybrid transformer SSM architecture with no retraining from scratch and no data leaving your building. The results show over 95% of teacher performance on retrieval-heavy tasks with 8 times smaller state. Measured head-to-head against the models that they were converted from on identical runtimes, our models deliver up to 3.9 times faster inter-token latency and throughput. That's the same model you trusted yesterday, just sized to run on a rack or in a air-gap facility or on the robot itself, and it keeps learning wherever it lands. What's defensible here really is the posture. So Frontier Labs won't hand you the weights you can run offline, since their business model depends on keeping that model and infrastructure in their own walled gardens. So let's talk about design partners, because that's what I'm here for. If you have a model you depend on in a deployment that doesn't fit on-prem, air-gapped on robot, we convert an eval checkpoint you provide against your own benchmark in an environment you control with no production access. Then we deploy inside your boundary and prove the learning loop with you. The converted weights are yours, exportable, self-hostable, open sourceable, no lock-in. On whether we can actually do this, so I've spent the last 10 years building out production systems. I've contributed to the Mamba architectures and the Mamba architecture in multiple inference frameworks, including Modular's Max inference framework. And our 6-person research team built the conversion pipeline behind these numbers on a H200 cluster. We're choosing our first design partners now, and if what you saw maps to where you think the industry is going, let's talk. You shouldn't be tied to an architecture or to somebody else's lab. Come find me, and thanks for listening.
Thanks, Evan. Now we're at our final founders. Thank you. Nosh is actually going to be providing some robotic cooked food right outside, so I'll hand it to him as part of the presentation.
Awesome. Very good afternoon, everyone. Yeah, it's lunchtime, or many of you had lunch. So, how many of you want to eat healthy? Okay, so, and most of the times what happens is we want to eat healthy, but on busy days, we don't have time, we don't have energy. So we end up doing takeouts or, doing eat out, and then we have that guilt. So in this world of AI, I mean, where we have discussed so much about AI in terms of AI can now speak, AI is writing workflows. In fact, on the roads, we see AI driving. So, but one thing which has remained untouched is cooking, which is fundamental to us. Food is fundamental to us, and that has not been touched till now. So if cars can drive autonomously, why is our cooking still manual? Was the question, or is the question we were trying to answer. So Nosh is a physical AI for everyday cooking. And where does the genesis lie, or why we even started building it? So yeah, here we go. So what we realized is that it is not that people don't want to eat at home or they don't want to eat healthy. They want to eat healthy, they want to eat homely food. Just that we always make a promise, okay, tomorrow onwards we'll start cooking at home and every day we'll eat good food. But then at around 6 p.m. or 7 p.m. in the evening, when we reach home, we are tired, and then our kids are hungry and they're waiting for food. And we end up doing either cooking simpler dishes, which we have always been cooking, those 3-4 dishes which are quick to eat, but then we get bored, or we end up doing takeouts. And then we have that guilt that, okay, we are not eating healthy, we are not eating the kind of food that we want to eat. And that's where to solve for this, so that's where we say that families don't lack intent to cook or don't lack intent to eat at home. It is just that they don't have a system that works for them. So that's where Nosh is a system which enables them, or Nosh is a system for manual to automated cooking, where users can just load the ingredients, command it to cook, and while they are spending time with their family, they are spending time with their kids, or maybe sometimes they are working late in the evening, Nosh is cooking parallelly for them. So how does it actually work? So this is the Robo Chef, which you see on the screens. You would have seen it outside. How does it exactly work? So on the Nosh app, you can choose your favorite recipe, be it in terms of soups or pastas or whatever you want to cook. You can select your favorite recipe on the Nosh app. Just load these perishable ingredients into it. Let's say, and also pastas are not boiled, by the way. You can add raw pastas. Nosh will boil it out. And you can just load it in and command it to cook. Nosh precisely measures amount of oil, amount of water, amount of seasoning. Also using camera and AI, it identifies the right stage to add each of the ingredients. So how we cook at our homes using our eyes. So camera is the eye for RoboChef Nosh, and that's how it ensures that your food is cooked to the right consistency and to right doneness. Also, you can personalize it to your taste, because I cannot say that, okay, I have programmed a recipe and the whole world will eat it. What I eat and probably what you eat is very different. So you can personalize food to your taste preference. Okay, I want less oil, I want less spiciness, I want less salt, or maybe more spiciness. All those adjustments you can do. You can also adjust consistency. Coming to the next important question, in terms of, so most of the times I get questions around, okay, why is AI needed and how do we use it? Or is it just that everyone is saying AI, so are you also saying AI? So why that is important is because ingredients have a lot of variability in it. Let's say if I take fresh onions, they'll have higher water content, and as days go by, water content reduces. So I cannot say that cook all the onions for 1 minute. So we use time, temperature, and vision. Even in vision, we look at color. So how you can see that the color of onion changes from, let's say, raw to translucent to golden brown. Or let's say in terms of shrimps. In shrimps, size, shape changes. So we look at shape, we look at color, and that's where we figure out if the ingredient is cooked or not. Coming to the most important question, can it cook for me? Or does it cook dishes which I love? So Nosh can cook dishes across cultures and cuisines, whatever you can cook in a pan or a pot, right from Indian to Chinese to Thai, Mexican, Italian, American. It cooks superb desserts in case your kids like. Also a lot of millet-based dishes for users who are focused on health. So that's where Nosh can cook across cultures and cuisines. And yeah, so last thing is, would love to invite you, all of you. We are there. We'll be cooking in some time. You can see the RoboChef cook, and not just see, you can taste the food cooked by RoboChef and tell us if it was actually good. So yeah, we are just outside, and you can come and you can experience the product. We'll start cooking at about 4:35 p.m. So yeah, looking forward to having all of you there. Thank you so much.
Okay, mate. I'm excited to looking forward to eat too. All right, I know we're a little behind. Apologize for that, but then some great founders. Next up is Sean Flynn with his panel. It's going to be amazing. And Allison and Marlo, come on up. I got the Sean Flynn fan club over here. That's what it was echoing. All right, your mic is on.
Perfect.
Yeah, I think do we share these? Does this work? Yeah.
All right, sounds
Testing.
good. Yeah. Everyone in the back can hear us? All right, everyone in the back moved their car from next door so it doesn't get towed? All right, it's kind of important. Last thing we want is someone to say, great event, but my car was towed, and, you know, give bad reviews. But, all right, so this panel, yes, there's the AI robotics. This is going to be more AI than robotics. So letting everyone know. Actually, before we dive into the questions, how about everyone gives a little bit of background of themselves? Alice, you want to go first?
Cool. Hi, so I'm Allison Mew. I am the founder of a AI prop tech company, property technology, so software, called Space Plan Wizard. In a former life, I came from the real estate side, so now I'm on the software side. I come from a very, what we call, dusty industry, so it's ripe for disruption.
Milo?
My name is Milo Poplar. I am a lawyer, so another dusty industry. I'm building an AI law firm here in San Francisco, and in a previous life, I was just a standard lawyer. So now, we're done.
All right, and I think everyone met me already, at least the SVH Capital team. We got a table out there, but we're an investment bank. So I'm not going to be doing much to talk. I'm just going to be asking the questions. The rock stars here are going to be doing all the answers. And the first question for you, companies over time, investors have been looking at them and judging them differently. We want to see this, we want to see that. How are the investors that you're talking to, your conversations, what type of metrics are they setting now for AI companies that might have been different than before or have changed over the last year, 2, 3 years?
You want to start?
Well, first of all, to your point, this rapid rate of invention, so the goalpost, the way it keeps changing, right? Even like what's pre-seed and seed and Series A and all of that, it's very confusing. I like to joke that stay pre-revenue as long as you can, because, which I'm sure no investor here wants to hear.
Wait, but because they all watch Silicon Valley show.
I hope we've all seen it.
Everyone got the reference there? Thank you. All right.
And the creator claims it's nonfiction. I would disagree, but that's another conversation. But of course, the joke being when you're in that ideation MVP, or if not even there, napkin sketch kind of stage, you can get a big check and sell this great idea. But I'm not kidding. The second you start generating revenue, you do start the clock. An obvious metric is revenue and ARR. I often like to say, if you have those slides, the problem, solution, why me, why now, the team. Of course, my least favorite slide, the TAM. I assume we all know, like, total addressable market. I hate it. We all make it up. But the thing about it that investors probably focus on it, and why I mention it is, if you drill down into, not just the TAM, but what, the SAM and the SOM, right? Like, for example, for me, real estate, great, how many tens of billions of dollars. But the reality is it's not just that global market, because of course they want to understand, at the end of the day, to answer your question, it's the size of the market. Like, how big can this become, and are you the next unicorn? And a lot of it's just their gut. So if you can show your thought process and drill it down to the SAM, so the serviceable available market, right? What portion of it? So like in my case, we don't necessarily focus on brokers or PMs, but like anywhere from an architect to a real estate professional, there's certain very specific user profiles. So from that that target market, what's my SOM, my serviceable, like more realistic, obtainable market, right? So even if I only get a small percentage, it could still be in the billions. So even just your thought process, I would say, is at the core to show that you can validate sort of and defend it.
I agree with everything. And I would really drill down on the aspect of you gotta show that you will make money for the investors. That's what they are after all. And if you are focusing on how this is changing the world, that might be great for some investors who are looking for that, but majority of investors really want to see how are you going to make money, what's your plan on capturing the market, how are you planning to do your distribution, and then once you go into my scale of what I do as legal, then it's about, do you actually own what you're selling? Can you show that your distribution is not reliant on someone who owns that technology that you purport to own? And so you want to be careful that you have what you are purporting to sell, and then you understand the distribution and you understand how you're going to make money to everybody who's coming on your cap table.
In the past, some people say, hey, that person's just a good storyteller. How important is still being a good storyteller now in the era of raising capital with AI?
I think it's everything. I think you should start storytelling much sooner than you need the money. I was talking to some of you before this panel, and a lot of the people that I talked to, they're saying, we're stuck on distribution. We now want money from investors, but we really don't have relationships with them, and it's really hard to start creating those relationships and showing what we have been doing for the past years. And so doing that storytelling in advance, targeting those investors that you want to target and eventually want to raise from is very important. I would also mention that most of the investors, most of their funds is distributed to startups that they want to fund. So you want to make sure that they already know about you. You're there, you're visible, and your story is great.
And I think sometimes a painful realization for those of us who are builders, history has proven this. It's not always the best product that wins. It's the best storyteller. And so really understanding what it is you're building and why it's not a nice to have, but needed and needed now. Just like some things can be a really great solution to a real problem, but is it investable? That's really big too, right? So you could still have a great company and it can still be meaningful, but these different metrics we're talking about and what a VC looks for, it's just different.
And we are going to open it up for a question or two from the audience at the very end. But before we even get there, okay, one thing that investors always ask, and it's the same word over and over again, you're just like, it's so painful. Tell me about your traction. Traction right now, pilot programs. What's a successful pilot?
So this is a big one that gets overlooked, and it's stunning to me. We're B2B, so enterprise SaaS. So the Fortune, let's say 2,000, you would think they all have a playbook at how to pilot software. I'm pretty stunned. I don't know if I found one, candidly. And it's literally every company name you know. It's wild. I learned the hard way the first time, so we're very aggressive and proactive about helping to structure it. So I call it the 3 T's, tools, training, and time. Even when you get through legal and finance and all of that and you get the tool approved, if that company internally is not providing training and time, and you should be a big part of it, and understand that business model so well. So in our case, if it's not billable, I went to a department to get a billing code so that they could get hours a week. There's things like that are really actionable, but that's why we're in, I think, what we call pilot purgatory. Adoption is actually very low on the enterprise side. Consumers different, so much less friction, right? But that's a big one that you could have the best product and the users could love it, but the users and buyers are different people at a company.
Can you dive more into that? Because I think a lot of people are confused. One, where to even start the conversation, and then two, how to get that internal champion to keep the conversation going?
Okay, that's the keyword, champion. You want clones of yourself. So, founder market fit, by the way, if you have multiple, I'm sure everyone has multiple brilliant ideas. That's why we're here. We're a little delusional. Our brains work differently. Build the thing that you experienced in the market and have founder market fit, you left to solve. So that means, though, you'll understand. So I understand, sometimes I feel like better than the end users, like their infrastructure. So create clones of yourself in-house, right? So in our case, if it's a company with, I'll make sure there's people that are given that title of a champion, and we create office hours. So create a recurring cadence. We have Teams channels where we're a guest on. It sounds so basic, but these are actionable things that keep you in front of them and clone you, because it's otherwise, how do you scale? And then you have people who own it internally.
How much time or effort should an early stage company focus on that first pilot, that second pilot, to get that survey, those case studies, get it, is this just something I met the person and hopefully they deploy, or is this something, hey guys, this is one of our key things that we're going to dive on and make sure we get updates weekly? Like, how much resources from the company should be focused on this?
So internally, when they're piloting. So we make sure those stakeholders that go to all the difficult ones, the obstructionists, usually that's IT. If it's finance, legal, we learned the hard way. Our first pilot, we found out at like the 11th hour that you have to be SOC 2 compliant.
I liked how Milo was nodding his head once you said legal.
Oh, legal. Oh, legal. Yeah, he needs to dive in on this one, but yes, exactly. So, but making sure that you convince the people who say no that they'll say yes, and if they feel like they own part of it and they look like, they look smart when it works. And they may all define their ROI differently. I'd be curious, like legal's perspective actually on that.
We were just trying to stall. Always.
No.
No, I think you want to make it easy for a champion to push through your startup through the process. And so you have to really ask them, who are you talking to internally? What is the issues that you're seeing? What do we need to deliver to you? How do we empower you to sell this to your stakeholders internally? And so for legal, that's usually what is the liability here? What happens if this doesn't work? Who are the sub-processors? How do they access our data? What happens if something happens to that data? So that's the legal side. Finance, how do we measure the ROI? Then who is going to use this? How do we ensure that it's going to be used well? And what happens if it's not used well? All of those questions, I think, are very important, and you really have to empower and talk to your champion and ask why do you need this, and how can I give this to you? And yeah, that's pretty much it.
So one thing I've noticed in the past, some companies, they'll have that pilot project, they'll have run this very successful campaign or whatever it is, and then never talk about it. How important is it to then later actually talk to investors about what was accomplished, what was done in these programs, and to get approval to talk about those to the investors?
That's a great point. It's very important to be able to talk about it. A lot of the times, big enterprises will not let you do that, and that's one of the things that we in legal are pushing back on. But you can definitely explain to your champion, again, I need this because this happens, and then I can go to investors and I can do this with this information. And then they can go to their lawyers, and the lawyers usually are just ticking boxes, right? It's a playbook. And if you can show to those lawyers, hey, this is very important for them, they can go get an exception, but the exception is much easier to get when it's targeted and very minimal. So I think you just want to be careful of what you want. You don't want to make big asks initially, and then perhaps growing those asks over time.
So two-part question here. Part one, and it'll lead into the second, but right now there's a lot of family offices that are starting to get more active investing here in Silicon Valley, where they want to bypass the VCs. They don't want to pay the 2 and 20 or whatever it is. They want to go directly to the companies, and they're getting more and more access to them. In your outreach, your conversations, is talking to these family offices a different conversation than talking to the angels or VCs, and how to go about doing that, how to play that game or that field?
Sure. It depends. Let's say you're talking to a family office. Who is the person who is representing them? What is their background? Is it a VC background? They'll probably listen to you when you're talking to them as to a VC. Is their background PE? You have to change how you're talking to them. You have to talk more about how a PE, talk to a PE. And then some family offices have different departments, right? And so they have a different risk profile. Different people within that department will look at it differently. Again, it's very important to sell to the person, not to the family office, because the people within the family offices will look at your startup differently, and you want to make sure that you're building your startup for success and not just, this is a family office, they look at it differently, they look at it this way, and don't really consider who you're talking to specifically.
And just to add on, it's my understanding that even in this current climate, family offices are often referred to as like more patient money. So compared to some of the other really fast, big X returns that you might see from VCs.
Okay, so second part of that question. So you got the family office, but there's times where these family offices are maybe from countries that may not be too favorable on the cap table. What happens when that situation arises?
Then you're going to DPA and CFIUS. So you want to make sure that they don't own more than 10%. If they are planning to own more than 10%, maybe they invest through a different vehicle that allows you for them to invest in. Essentially, once it's more than 9.9%, you want to involve a lawyer, definitely, or just do safes as far as you can.
That's interesting. Why did you just say that? Just do safes?
It's debatable whether that's equity and whether there is control that you need for CFIUS. So you can get a safe, and then when it comes time to convert it, lawyers will figure something out.
Oh, lawyers.
I mean, that's what we do.
That's what we do.
Question on that. So piggybacking a little bit on that question of, where's the money coming from in different parts of the world. Right now, one area in Silicon Valley that is getting more and more attention, companies that are labeled dual tech. How does that label are there concerns, are there thoughts, are there anything that people that label their companies a dual tech should be aware of right now?
Yes, don't label yourself as dual tech publicly. Not great. Definitely you can talk to investors that potentially your technology can have a defense.
Maybe before that, the definition of dual tech, or what is dual tech? I'm guessing. Yeah.
Dual tech, dual use essentially means you can use your technology for civilian purposes and then for defense purposes. And as soon as that happens, and you are actively showing that you are dual use or dual tech, then there are multiple more regulatory issues that you have to deal with. So not going there early makes it easier for you to grow and to get potentially more outside capital from outside of the US. As soon as you go into dual use, then it becomes much more difficult. We have seen some of our clients essentially say, hey, if everything works as we want it to work in the year and a half, 2 years, it could be used as drone radio, but until that happens, it's just a radio. And so we are not a dual use technology until it becomes tangible.
So two questions before we open up to the audience for a moment or two. Alice, you said something on our prep call for this, which I love the quote, and I'd love for you to kind of go a little bit deeper, that startups die by suicide, not by murder. Can you explain that?
And in all fairness, right, I heard it from even a Y Combinator from Paul Graham. And,
but you made it famous.
I mean, I will tell you though, it really, so those of us, we always struggle with like stealth mode and competition and like just how to handle that as we're like maybe in our MVP stage. But think about it. First of all, competition proves the model. And also, it's internally, it's inflicted upon us ourselves, right, if you think about what it means. And so the reality is, of course, you should understand the market, and yes, the paranoid survive, I'm sure we all are, that's fine, and know the market, but you can really lose a lot of sleep over it. When the reality is, if you just remain innovative, go ahead.
I'll maybe just add that most of our clients, if they fail because of a founder dispute. And so I would look at it as marriage. You should really consider with your co-founder to go to like couples therapy. I'm serious. We take care of 3 to 4 founder disputes every month. And the biggest issue is that they have not talked to each other and kind of opened their grievances to one another for far too long, and they are too far gone. And if they did something else months earlier, it could have worked. It could have worked, and now the startup's dead. And they can either kill it quickly and have a chance of raising money again, or they will be really salty about it and they're done. And then you can go back to Google.
Speaking about communication, one thing that I'm seeing more and more, companies stay in stealth longer than before. Maybe that's just me, but are you seeing that? And when is it time to not be stealth, or maybe go out to the public, then go back to stealth? Or how does that all work?
It's so easy to stay there. You invest all this time and energy, and left's probably a great job because you're convinced you're the one to create this disruptive thing. But I would argue, fight against that and get out there. I'm now obsessed with user feedback and speaking and talking about it, because you could have all those metrics and have founder market fit, but even with a great product, there's nothing, aside from being too late, being too early to the market. Sometimes the market's not ready for you. And wouldn't you rather learn that sooner rather than later?
All right, let's open up for one question from the audience, maybe 2. Any questions? While the audience composes their question, what are you guys looking forward to in the next year here in Silicon Valley?
It will be really interesting what QWERTY said, the founder from QWERTY, how closed models will work against open source models. Even for us in the legal field, I think Claude and ChatGPT is kind of done, and it's more about how do you work it inside the company, and for that, open source models are just much more efficient. So I'm interested to see how the closed model companies will compete with that.
And of course, we're all familiar with the horizontal, all the agnostic. I met a Claude here earlier today, the other Claude. But I love a vertical, and I'm excited to see, the disruptive, those next upstarts really disrupting industries that desperately need it to come into the new era vertically with AI.
All right, one question from the audience, yes or no? All right, if there's, yep.
Okay.
Just yell it out, I'll repeat it.
Okay. So considering that the government bonds at the top high right now, and I think the era of the cheap money is about to be over, how do you think investors will make decisions into the early seeds startups?
Repeat the question.
Yeah, you're gonna have to. I think you'll have to repeat it.
Considering that the government bonds yields are a top high right now, I'm considering that the era of the cheap money is over. What do you think about investor decision into the investing early seeds startups? How it will change?
You want to take?
Yeah, I don't know.
Well, I certainly can speak from experience that area between whatever these words mean, pre-seed and A, that's really, really challenging right now. And it's the part where most die, right? Where you maybe have your MVP or get a little traction, but it's not enough. So I don't know how much or how differently it'll change based on some of the metrics that you mentioned, but I do see it currently. It's changed a lot from the last few years. Obviously, there's more competition. You can leverage, you can vibe code, you can ship things faster. So it just, it feels almost harder almost to attain. The goalpost has changed a little, right? So before it might have been $500,000 or $1 million ARR, now it's 2 to 5. There is a huge opening there, though. If you can just make it through, I think that you have a lot more ability to access capital.
Could I add? I mean, one thing that I would like to add to that is, I mean, look at the amount of capital waiting to be deployed, because right now, if there's more companies than that capital, yes, they can keep raising that standard, raising that bar. If there's that more capital more capital than the companies, then the bar can go lower and lower and lower, because the investors that have raised the capital, their goal is to deploy the capital because they want their management and their carry and all those fees. So look where that capital, the proportion to the companies that they're funding and that kind of relationship to kind of see where the money's going to go. And there's always a lag. There just is. I mean, looking at the private, on a little tangent here, the private equity, that's an area that we play in and have a lot of conversations. There's so much dry powder that you see their bar, it's continually lower and lower. Before, hey, it needs to be 5 million EBITDA for us to look at it. Then it's 2 million EBITDA. Now it's 1 million EBITDA. Now I hear some private equity groups, as long as they're profitable or on their way to profit, we have a platform that we can tuck them in. They don't want to give up the capital that they're holding in the back, and they know they need to deploy it, or their LPs are going to get upset with them. So, just kind of look at that relationship, and always ask VCs, hey, what are the conversations with the LPs? How easy is it to raise your next fund? All that stuff, and you'll get an idea of what the market is saying at that time. I know I'm the moderator. Back to you guys.
I would maybe just add that LPs would always want to diversify. And so here there is so much money in Silicon Valley that there will always be a lot of diversification to the funds here. So I don't think you have to worry if you're here. Other parts of the world, probably more difficult.
All right, we're just about on time. Mile, Alice, can you guys give a little handoff of what your company's building, what you're working on, all that good stuff, and if anyone wants to find out more, how to go about doing it?
Sure. Fellow Legal is an AI law firm here in San Francisco. We are working exclusively with startups and their investors. Our specialty is helping foreign startups to come to the US. I am originally from Czech Republic, so I take a lot of my European startups to come here. And then we have Larry, who is there. He's from China, and so he takes a lot of Chinese startups here to the Bay Area. And the AI part of Fellow is that we really think that legal is a data company. And so it's really about making sure that the data that we have really serves the client. And for that, we need to have a very good data right in time when we need it.
And Spacepan Wizard, so as I mentioned, prop tech, basically we leverage machine learning. So from 2D plans, there's a ton of really magical data from a floor plan that you can extract that, believe it or not, like the Fortune 2000, if you ask them something very basic about their real estate portfolio, how much square feet's on a floor, they actually don't know, which is pretty stunning when it's the second most expensive line item after payroll. So it helps just kind of centralize and help them understand their physical space. So most RTOs, return to office, fail because companies don't know how much space to lease, and that's because they don't know how much space they have. So it helps. So anyone with real estate or office space in particular, we're here to support.
All right, I'm Sean Flynn here at SVH Capital, and with that, let's give a round of applause to the panelists.
Thank you, panelists. Now we've, again, everyone, we have an amazing program for the rest of the day, and got some good food prepped up and some amazing drink that Ken Hurley's going to be providing as in addition to being a panelist. So with that, Sonia, I want to have you come up, our moderator and events extraordinaire, to lead the next panel. How's everyone going? Enjoying the panels and the network? Doing great? Awesome. Thank you again for being here. A lot of folks that came a little later, we just want to give acknowledgement for you to spend your time with us. So with that, I will hand it to Sonia. AI and smart cities. Want water? Huh? One bottle of water? Sure. Mics are up here.
We are sharing this microphone. Yeah. Hello, everyone. I am Sonia. You must have seen me in the back fiddling with cables, lots of them. But thank you, everyone, for sticking around. And I'm really excited to host this panel. We are going to talk about smart cities, right? And what goes into the making of these smart cities, what can we expect, and how the smart cities will help human beings hopefully become smarter, not dumber. So let's get to it. Again, I'm Sonia. I'm also one of your hosts, and I'm very excited to have our three esteemed panelists here. I am going to just ask the panelists to introduce themselves. So starting with Nav Chetan from YCurb.
Thank you, Sonia. This is Nav, co-founder and CEO of YCurb. And we provide a curb management solution that we call the Curb Operating System for the cities.
Hi, thanks for having me. I'm Dominic Lee, avid inventor, programmer, and CEO of Gyropalm. Essentially, we create human-computer interfaces for controlling robots, appliances, computer, electronics, and IoT devices from anywhere in the world, and industrial smart factories as well. So we have patented award-winning technology that helps different people in different various industries for automation.
Hi, I'm Kenneth Hurley. I started Genius Ventures and Genius AI, which is a swarm network for AI, basically, running on our own blockchain. I patented that in 2019, started developing it in 2016, and it's pretty much finished right now, and we're about to launch it. But it also goes really well hand in hand with AI and robotics and industrial transformation because it's AI, swarm network AI on the edge, so you don't need any centralized servers.
Ken, I would like to start from you. So since we are on the topics of smart cities, what I would like to ask you is, when we talk about smart cities, we are talking about the dependency on intelligent systems. Now, what do you think will the AI-powered city of the future really look like?
Well, I firmly believe that the frontier models and the centralized servers are kind of going to go away or be reduced. They're going to be, for big enterprises and stuff like that. But for cities, they're going to want to own their own data, and the power cannot be, centralized, and so they're going to need smart cities that have their edge-based devices that you don't need a centralized big power, gigawatts or petabytes or petawatts of power. So I really think that the industrial transformation is also part of that. It's very similar. I think of an industrial facility as kind of like a mini city, right? And if it has a bunch of robots in there and, doing work or whatever, then they can have a swarm intelligence. And so I think that goes really well for basically for, sustainability as well, because now you don't have to build these massive data centers and waste water. And so I think everybody's going to start realizing that that's the way the infrastructure is going to have to go. And then cities are going to know that, hey, we have all these devices already that we can use, and they'll just kind of put them together with software and create their own swarm network.
So the future is decentralized.
Yes.
And we're not just talking about decentralized on chain, but we're talking about decentralized energy and a lot of decentralized tech. Okay, continuing along that same conversation, Dominic, you have been building robots for over a decade now. I would love to ask you that for smart cities to work, what do you really think an intelligent physical environment would really look like?
Yeah, so in industrial automation, there's a lot of different machines, and in previous years, a lot of these machines, although sometimes they performed what they have to, in order for the next generation of machines to grow alongside physical embodied AI, there needs to be a certain unification of platforms. And right now, there's certain companies that are trying different types of tool chains or interoperability, development stacks.
But there's one key disconnect, and that key disconnect is how do we connect large language models, AI, edge-based models, so that everything is more interoperable, everything is more interconnected. And so there's a lot of different frameworks out there. Our company actually creates one of them called Vimpact. But there's essentially the major need to bridge all this together is a unified framework where devices know where each other are. And the other thing is to know where the human workers are, because there's a lot of concern in the industry that, AI is coming, I'm going to be replaced. Well, unfortunately, fortunately and unfortunately, that's not the case. Human operators are still very much needed, and they will be, and that's the good relief. But the bad side is there's a side of AI which aims to completely replace operators in ways where operators are still needed. So where that divide heads, I think the perfect thing is to have an interface that not only makes it more interoperable, but to add human in the loop. We're talking about a system that knows where operators are in proximity, where they are to machines, what's the current intent that needs to be done to make these facilities actually smarter.
And I believe it won't just make these facilities smarter, it will also make these facilities safer.
That's correct.
Because a lot of this industrial automation, it's used in places like oil rigs, right? A lot of places where the environment is demanding, changes in sensors, changes in temperature, pressure, all of that could trigger a chain reaction. So smart cities, of course, we are all worried about robots taking our jobs, but if those robots can also help provide a safer work environment, I think that's going to be a big win. How many of you drove to this venue in a car? Okay, that's roughly 50% of the people. Some of the people are like, I'm not sure whether, the Uber I took really qualifies as me coming here in a car. Okay, how many of you actually got here in a car, whether you drove it or whether it was an Uber? Okay, almost the entire room, right? Now, we know that the whole automobile industry, it started in 1886 with one person. How many cars do we have on the street today? Anybody wants to throw a number? We have 8+ billion people in the world. How many cars on the street? In the world. 8 billion people in the world. How many cars on the street? 2 billion. 2 billion? 100 billion? Okay, well, that's too much for 8 billion people. That's like 10 cars per person. But, Kevin is very rich. Yeah, I think usually people don't own those many cars, and that's also I think it's also just a side effect of us being an American. People are like, oh, everyone's rich, but that's not true. However, you were very close because there are 1.5 billion cars today, approximately 1.5 billion cars, which is a lot, right? And then Navcheet, with that information, I would like to segue to you because a lot of those cars are in the United States of America, and you have a solution that's about digitally managing the curb, right? Looking at the curb as a digital infrastructure. So then, how do you explain this to the city? Your startup basically tells the city that you have to even look at the curb as a digital infra, and how do you convince them to do that, and why should they do that?
Yeah, so thanks for this. So the problem is the current solution that cities are using for parking and generating revenue from parking, it's a legacy solution based on hardware, whether it's parking meters or other such hardware. Now, the problem is drivers don't want to use that solution. Drivers don't want to feed the meters, spend any time searching for spaces, or feeding the meter, or reading the confusing signboards. So they just want to check in and check out. The problem is the solution and the consumers, they are not aligned. And that's exactly what we do. So that is where the digital infrastructure comes in. We create the digital twin of the curb inventory and pack that in a solution, whether through app or APIs for the drivers to consume, so that they can simply check into the curb and automatically check out without having to feed the meters or spend any time other than the purpose they are there for the visit. So we get rid of this friction from the parking experience for the drivers. And for the cities, it means zero hardware-based solution. There's no CapEx, there's no OpEx. So this way, the cities and the consumers, they are aligned, rather than fighting against each other, where cities is trying to monetize the curb and drivers are trying to get rid of or not use the meters at all, right?
So what I would like to ask as a follow-up question really is, we are talking about smart cities here, right? So curb management is going to be something that we all are struggling with even right now. But at the same time, we see so many autonomous vehicles also, right, joining the ranks of vehicles driven by people. So in this case, how can we leverage real-time data, which is not how things are being done today? I think there are some smart parking garages that we go to where you can see that, hey, on X level you have X parking spots, and then you can see a green light. So you follow the green light and that's where you get to park. But unfortunately, that's not the case when you are in a city. And Ken will attest to it, but every time we have an event in San Francisco, the first thing I'm looking up is, okay, where is parking? And then on the day of the event, we send out an email with parking instructions because unfortunately, we have to usually drive since we have supplies. But if I'm attending any event in San Francisco, I'd take the long, arduous journey on BART and then get to the event versus driving there. So what I'd like to ask you is real-time curb data, how can that help cities make smart decisions, not just for people, but also this growing slew of autonomous vehicles that we are now seeing get on the roads?
Yeah, so that's the challenge the cities are not prepared for yet, which is the question is, how would cities track and charge autonomous vehicles for the curb usage, for their parking? The autonomous vehicles cannot pay using parking meters. Autonomous vehicles cannot pay using parking apps. So the only way out is a digital infrastructure that the autonomous vehicles can consume so that the autonomous vehicles know where they can park. And then cities, using the same API integrations, can track the location of the autonomous vehicles, GPS tracking, for example, and this way automatically charge autonomous vehicles with zero hardware, which in our opinion, cities are not prepared yet.
Got it. Since we are on the topic of autonomous vehicles, I think a lot of you guys would have read really funny news articles about how there was a Waymo, I think, that dropped off 2 teenagers who were drunk and who were just misbehaving with pedestrians on the street. The Waymo just took them and dropped them off in front of a police station. Right, so on that topic, Dominic, I would love to get your perspective on how do you see human-robot interaction? How do you see that evolving? How necessary is it that this particular interaction has to be intuitive, right? And how do you really see that evolving from where we are today into where we might be a few years into the future?
Right. Yeah, so human-computer interaction, it really depends on several things that are markers, different types of intelligent markers. And a lot of people, when they think about human-robot intelligence, for example, right now, in the current state of the art, we're not in a situation, right? The current state of the art of the industry is not in a situation where they can fully address, for example, if you go to inside an autonomous vehicle, it doesn't exactly know who you are just by looking at you, and the best it can do is face recognition, right? The best it can do is make you type in your name, or maybe use Bluetooth on your phone, or use some type of wireless technology. But the key question is, how does something really know it's you? And that's something that I address with the company that I lead. But also the other thing is that in order for a technology to really truly know who you are, it can't be susceptible to being, spoofed. And that's a very big thing. If you think about it, every one of us nowadays holds a credit card, right? A credit card that has a wireless tag. Well, of course, you still have to sign your name and everything, but let's say you tap that card. Well, what if somebody else held it and tapped that card? They could still be you. I mean, the machine still thinks it's you. So for us, we solve that challenge through the combination of semantic intelligence. It could be a mix of AI and a mix of wireless integrated technologies like wearables, and a wireless integration of facial recognition and proximity, user proximity. And I specialize in one thing where proximity through authentication is very important. So not just who the user says they are, but realistically, what are markers that show that they are really in fact there? So for example, with the door access systems that we've built, we make sure that users are truly there and who they say they are before we unlock, right? So geospatial recognition is a very important one. Another aspect is, do you know the user that is truly really them is by issuing tokens that are temporary, right? So if I give you a key and you drop that key, what's stopping from another person from using that key? So that's the same exact thing that we do. Even with our wearable tokens, we make sure that they're interchanged, that they're refreshed, that the user always acknowledges who they are. For us, we choose to do it with gestures, but it can also be done through other means. And so having this authentication is very important. You could use biometric authentication, you could use facial recognition, combination of proximity, and all these different types of sensor technologies. But the important part is you never want it to just be in a possession of, right? For example, like I said, a key. If you drop it, somebody else picks it up, it's gone. Right? So you really want to make sure that is a very sustainable and solid aspect to a dynamic growing ecosystem, especially one where the AI is assuming who you say you are.
Absolutely, I think, and especially with AI bots and digital twins and all of these narratives becoming mainstream, it's going to be harder to differentiate between who a real human is and what's an AI agent, or especially an AI agent that's acting on behalf of a malicious entity. That is a scary scenario, and we have already heard stories of people dealing with that. But since we're talking about intuitive systems, intuitive interactions, how many of you ever experienced Walmart's self-checkout? They used to have like a handheld device. I mean, not just a checkout lane, but they had a handheld device that you could literally scan while you were shopping, and then you just went to the counter and you checked out. Has anyone done it? It was a really small, okay, I see a couple of hands going up. It was a really small pilot, and it took place in only a few cities, in a few cities and a few centers. And one of them was at Milpitas, where I live. And I remember using it, and I was like, oh, this is so great because, it saves me time. And then what they used to do is they would do some spot checks because, they wanted to make sure people were not walking away with things. And what happened was, when I went to the checkout, they were like, we're going to spot check. I said, yes. And they did find 3 items that I had not scanned. And I felt like, oh, I'm a thief. No, I'm not a thief, okay. But the thing is that when you're shopping, sometimes, you are not used to it. So there were times when I put the item into my cart, but then I forgot about it. Compare that to like maybe some of those self-checkouts at Amazon stores and stuff, right, where you can just get out. Now, what I would like to ask you, Dominic, from this example is, of course, when Walmart was deploying this, there was an element of trust, and it was taken down within 30 days, right? Probably because there were more people like me who unintentionally did it, but also a lot of people who intentionally did it, right? Now, what I would like to ask you, especially building on this example, is, you have deployed robots at scale, and what I'd like to really ask you is, what are some of those things that real world misses, right? Like your real world deployments could miss, that you see in the real world deployments that you could easily miss in simulations?
Right, that's a great question. So there's a lot of people doing simulations, whether it's with NVIDIA Isaac Sim or whether there's different types of things like Gazebo and ROS2, Robot Operating System. There's a lot of different ways that people are experimenting with AI and simulation and simulated robots. Now, that's not to say to criticize the idea of a simulation. That's great. It saves a lot of cost and it proves a concept and everything. But there is a major disconnect between taking something from sim to real. And it's not as straightforward as most people think, because a lot of people perhaps think, okay, if I can replicate something in simulation, I could replicate this in real life. But in real life, there's real life physics. There's kinesthetic torques. There's different types of things like friction coefficients. There's things like human dynamics. For example, you might be testing something in a simulator, and in real life, there's human beings who are walking around, and your robot it would have never ran into that situation. And so with reinforcement learning, there's a big caveat where I like to tell people is like, the best simulation is the one that you do in real life, right? And if you can't do that, collect data in real life and push it into the simulation and then match your digital twin as actively as possible, as accurately as possible. Because the idea is that there's always going to be one thing that it didn't account for. So with heuristic learning in AI, there's one big pitfall, which is your sensors have to really, really match those of the virtual ones that you have modeled inside your simulator. And if you can't model that, there's certain things that you just really can't model. And the best way to teach yourself to do that is to do both. And unfortunately, without sufficient capital, a lot of people probably don't get the luxury of always doing both. But with people who approached me before with that dilemma, I would just say, do the lowest cost barrier you can. So if you can't build the actual product, well, maybe build a smaller scale version of it, but you still have to have something physical in the real world to test your hypothesis, because maybe it doesn't work out when there's more humans around. You know, tech demos, even with the biggest billion-dollar companies, everyone's lined up and waiting on stage, and they're like, oh, okay, we're going to do a demo. Bam, it fails. And it's not because the staff was doing a bad job or anything. They might be trying very hard, but
someone gets fired, though.
Well, but that's because one thing is because they would have tried everything in simulation, but for that specific instance, they didn't try in that specific environment. So the environment matching the simulation, the environment matching what happens in real life is very, very important to success in production. And for us, we have done that confidently with different types of environments, different types of clients. There's one thing that I do as a founder, and you know what that is I like to go out and visit my clients and and check up on how they're doing, because that really pays off in the long run. One, it shows sincerity that you care about your client's success, and I certainly do. But our team also does one thing more, is that we check with them not only to see if the robots are working, but we check for extra dynamic variables that we may have not addressed before, and we address them quickly, right? So that's a very key important insight that you can't really catch in simulations.
How many people in the room are from product management? A couple of them. So this probably reminds you of, the Gemba walks, right? You go to the client's place, you sit down with them, and you really understand how they're building. So that you could take that input back to whatever you're building and then just build a better product. I would like to ask the audience, right? How many of you remember a Microsoft outage where a developer accidentally introduced a bug and then flights across the United States, in fact, actually across the globe, flights were delayed? You're just one person? Okay, a lot of people are nodding their heads, right? So we have every now and then. It's not Microsoft issue, it was a CrowdStrike. Well, it was traced back to that. All of these were running on Microsoft. On the Microsoft stack, and then ultimately, it was traced back to what really happened. But the point being that you have a lot of such instances. This is just one of them. You have had issues with data centers getting heating up, and then servers going down, right? And then suddenly you have thousands of people with their websites not running. They're unable to access their email accounts. But now we're talking about things like AI systems becoming a part of our daily lives. So Ken, I would love to ask you this question, that as we talk about AI becoming a part of our everyday life, and we're talking about cities and infrastructure around us integrating AI into our ambience, right? How important is it that the cities also look at distributed intelligence, so that these scenarios that we discussed, right, we don't run into them and something mission critical doesn't fail, and we just end up building systems that are more resilient?
Yeah, so to your point, actually, I think the better scenario is GitHub 2 days ago. Basically, everybody was they were offline for 7 hours. And so that was really hard for everybody because it's a centralized server, and they had overloaded it, and some routing and load balancers had got overloaded and all that. And so it took down many, many developers for 7 hours and was pretty disastrous. But in general, decentralized and distributed better, actually. Decentralized is kind of a misnomer. Really, we're distributed. And that allows you to self-heal because you have dynamic nodes, right? And they might be sitting idle and not doing AI, and then one of them goes offline, another one picks it up. And so that's what we built, definitely. And also, Elon mentioned this about cars. He was talking about making a swarm network of all the Teslas because they have a GPU in there. And so this would actually be really good for payment systems like they were talking about in the smart cities, where those guys have their own GPU going on, and they have AI, and they're in a swarm network, and they can talk to each other across the city and say, hey, there's just been an accident. And to his point, the whole thing you can't simulate is chaos. right? There's no way to simulate chaos because you just don't know the variables to simulate it. And so if there's an accident somewhere, that just happened at 5 o'clock rush hour, you can't simulate. Well, you could simulate it, but it's like, okay, exactly where did it happen? Where are all the cars? And it's infinite possibilities. And so simulating chaos is impossible. So I think decentralized, though, helps self-heal so that you don't go down and you don't disrupt people. And so it's all about, making things smooth. And, the cars, for instance, if they're starting to talk to each other, they can say, hey, avoid 5th Street because we just had an accident there, right? And so I think that's, I think distributed and decentralized, but really distributed, it's a little bit different. Distributed is like everybody talking to everybody else. Decentralized still has a gate. And so what we set out to do was you can't have one point of failure. And so with a distributed system, you don't have one point of failure. That's the gate for everybody else, and that's what you have to try to work towards.
You have to identify the bottlenecks and single point of failures in your systems and then make sure that those are in fact converted into distributed modes. Yeah, that's a good point. Since we are talking about swarm intelligence, I mean, a lot of this stuff definitely sounds like straight out of AI movies, right? The futuristic cyberpunk movies. I just hope that we end up into an era of solar punk, though, where everything's rosy and not cyberpunk. But we'll see how where all of this leads. With that being said, we obviously are at circuit launch, and then outside you see so many robots dancing, giggling, cooking food for you, right? So Ken, my question to you is going to be that, hey, we are moving into the age of not just digital AI, but physical AI. And so where do you see are the opportunities for the convergence of digital and physical AI, especially when we're talking about the realm of smart cities?
So I don't think we're ever going to get to Skynet, let's put it that way. So I hope not. I don't want to run into a Terminator for sure. But I think the digital side of things, there is a need to make sure that AI is doing what's good for humans, right? And so that's how I think we can avoid any kind of disastrous AI stuff. But there's the other side. They can use it for whatever they want. And so it's very difficult for me to try to figure out. I'm just pushing, that I'm always going to do AI for good, and I'm going to figure out how to do that. But in general, if you have a hammer, you can hit it with a nail or you can hit somebody in the head with it. And so what's your choice? And so it's all human choice that comes down to how we're going to make AI safe. And I don't think there's not a solution because, you have humans involved that can use it for nefarious purposes. But in general, if we try to, you have to battle good with bad and bad with good. So it's just going to be a never-ending battle. And but I think the swarm networks, like I said, if you're in a city, an industrial place, for instance, they all have these nodes already there that you can leverage. And so you don't have to build these high infrastructures, heavy infrastructures and all that. And so I really think that's where the blend's going to come in, is existing hardware, existing electricity. And I won't say it won't happen, but space, I don't think that's going to be necessary, actually.
Got it. So yeah, we'll have to see, almost every big guy out there is trying to get into space and do things. So we'll see what comes out of it. And of course, we're talking about swarm intelligence in cars, and we are talking about urban mobility here. So Nav Chetan, coming back to you, I'd love to ask you that how do you think cities can really tackle the challenges of complex urban mobility, especially with the number of cars, again, on the rise? Ken spoke about swarm intelligence. I would love to get your perspective as well.
Yeah, the only way out is digital infrastructure. The cities,
the digital twins.
The digital twins. So, like I said, the future is coming fast. We have autonomous vehicles. So the only solution out is cities creating digital twin, which means with zero capex, zero opex, all the curb users are aligned. They have zero friction in the parking experience. They simply do the deliveries and check out. The more friction in the parking experience, that's not good for the city's local economy or for the overall business. So the digital infrastructure is the only way out. Now, having that said, the future is moving towards drone-based deliveries. Or then there are universities who want to follow the same procedure where they want to go less on infrastructures, and then more and more autonomous vehicles are coming to the university campuses as well. To support this, drone deliveries and these autonomous vehicles in the campuses, again, we need the digital infrastructures. So for example, with drone deliveries, again, how are cities going to track and charge those drones using their pedestrian side to deliver the goods? So again, the digital infrastructure, the GPS to track the location with no hardware, so that we compute how much curb or the pedestrian side is being used by these robotaxis, drones, autonomous vehicles. Because in this case, again, hardware, parking meters are irrelevant and obsolete, which cannot be used by autonomous vehicles. So the way forward is the digital infrastructure only, right? Now, the faster the cities adopt to that, the more prepared it will be. Because the problem is, in the current status quo, the cities are not prepared for this solution, but the gig economy and the delivery companies and the delivery vehicles, they're moving more and more towards autonomous vehicles and AI. And that is causing a friction between the cities and these companies and startups.
So what I hear is, of course, digital infrastructure, we are looking at that as a solution. And it also seems like we would need to focus a lot on constantly evolving digital infrastructure, right? Because every so often we have sections of the road cordoned off because there's something happening, and all of that needs to be immediately updated into the digital infra. Now, we have been talking about drones, autonomous vehicles, all of this being added. But Dominic, I have a question for you. But when you're talking about all of this great stuff, you're talking about new things that will come, that we will see in the future. But what about introducing robotics to the masses without necessarily having to buy new infrastructure? What can the cities and what can industries do today with their existing infrastructure while gaining access to all of these new age capabilities?
Mm-hmm. Yeah, so there's a lot of robots that are existing out there, and there's a lot of robots that are autonomous in certain forms and fashion. There's humanoid robots, there's mobile autonomous robots, and a lot of them revolve around some certain stacks, and some of them, like I said, was robotics operating system, ROS or ROS2. And there's some robots that have an existing REST API, which perhaps has documentation on how they work already. But one thing that for example, that I've been doing with our team is we actually create frameworks that unify these things so that human integration becomes easier. And I believe in the future, a lot of more different types of people and enterprises would lean towards this type of an approach where they work with existing infrastructure, and this infrastructure has been existing in different types of protocols. For example, there's a lot of people in the industry who knows what Modbus is. A lot of people know what UDP, these are underlying stack infrastructures, but there's going to be newer protocols up there that sit alongside, large language models, things like MCP, and these are actually going to be connectors. But the main thing that I want to emphasize is with these, there does come minor risks, but those risks can be addressed. For example, to prevent volatile outputs, I think people can actually address those things because, as many people know, AI is algorithms that are comprising of mathematics, right? There's gradient descents, meaning if you tell an AI an instruction, it's going to find the lowest cost technique computationally to find the closest answer that can get to that's accurate. But the problem is, unless you give it ethical constraints, right, it's going to find different ways to accomplish that. And then so there's people who in AI companies that made sandboxes, and they thought things were sandboxed, and they tried to accomplish that, but then they tried to integrate that anyways. But I think having those things in line with the infrastructure of different robotics, I think that's going to be very much the future, and I think that making that interoperable with human control as well, human in the loop. So I can say, yes, that's correct. No, don't do that. Having that supervised type learning or on the spot is very, very important aspects as well for the industry to remember.
Thank you, Dominic. Actually, I would love to ask Ken for his opinion also on this, because we're talking about AI influencing critical infrastructure here, right? And then how do you introduce human in the loop or human oversight and resilience in order to balance the automation part that is completely being cared for by AI?
Yeah. So I thought a lot about this actually because the agent harnesses and the when they've injected code into NPM packages and stuff like that, which affects your MCP, for instance. And we actually developed a secure MCP, and what it is basically, this is where we put humans in the loop early, where we can say, that's signed, just like Windows signs applications, right? Like an App Store signs the applications, or the Google Store, or the iPhone Store, they sign the applications. So you're guaranteed that they're probably pretty safe, right? And so we developed a kind of an MCP protocol in our Genius AI system that basically is like a signing part of it. All of our MCPs are written in C++, but we allow other MCP protocols to be developed in Node or JavaScript actually, but then we compile it and then we have to sign it to make sure that there's no injected code. When you're running agents now, you download an NPM package, it's source code, right? And so they can inject whatever they want in there, and it's not, and yeah, they're signing on NPM packages, but they figured out how to get around that pretty easily because the keys get, hacked and somehow, and so they've been able to.
Not somehow, it's because the developer just puts the plain text key in the code somewhere.
Sometimes that happens, and other times it's been kind of, they're pretty tricky in how they can get that stuff sometimes.
I think North Korea excels in that area, of course.
The last thing I want to say back to a little part of that is that, we're going to train our models, and we call them expert language models, but they're just they're just very, how you or take care of chaos or things that you can't simulate is we have something called egg roll that actually learns based on what it's doing, and it can go into culture fit. It can go into language fit. It can go into like a specific region in a country that does something different in what they think is good. And so the problem with all of this, hey, how do we make this safe and how do we make it good? Good is actually subjective sometimes. And I hate to say that because for me, good is, I know what good is, but you go to another country and, marrying somebody under 18 is okay, right? And so how do you gotta tailor it to, certain cultures as well as language and regions. And so that's what we did was we built our Genius cognitive system that does a baseline language model, and then it uses egg roll to basically train on the area and what other people around you in the swarm have been doing.
Got it. Thanks, Ken. So I would like to use this opportunity to take a couple of questions from our audience. Does anyone have any questions for our panelists? I see one hand up there. Hey.
Hi. Thank you very much for the presentation. I got two specific questions for Dominic and the gentleman in the middle.
Navchetan.
Yeah. First one is, how would you enable a good digital twin environment? Second one, when you match a digital twin to a simulation, what do you mean by an accurate match between both of them? Thanks.
I can answer the first one and then you can do the second, right? So, well, of course, depending on what is the digital twin for, but I'll take our example. So, for our company, YCurb, so one of our clients, City of Tacoma, so we create the digital twin for all their curbside inventory, which means where are all the on-street parking spaces? Now, the baseline is if we can get a reference image from the city itself for all those assets, like the signages, the 30-minute loading only signage, or the fire hydrant, or the bike rack, or the parking meters. We get actual in-field images. We use those as reference images to train our algorithms. And then our smart AI-powered camera that we deploy on our vehicle, it drives around the streets of, let's say, Tacoma, for example, our client, and it captures all those images using the reference image that was originally used to train the algorithm. So the better this training, the lesser the errors when you actually capture the images. And of course, you have to, there's a QA loop that you have to iterate to see if there are any errors. So the training the algorithm, I think, is important. So the initial input data that is used as reference is very important, I believe.
Right. As for the second question, I believe you asked what would be a good criteria of, or what would be a method of determining whether there's a good or accurate match between the digital twin simulation and the actual occurrence. I'm sure maybe a lot of you know what is a blind test, meaning if you have a control group and you have an experimental group, you both test them, but you don't tell them how you're going to test beforehand or what you're comparing it to. So here's the thing. When you're doing a digital twin, first you want to analyze your experiment. So what are you trying to accomplish with this digital twin? So let's say, for example, I have a motor, and I'm going to move this motor forward 5 seconds. Okay, you're going to try to do that in the digital twin and do 1,000 experiments like that. And then you're going to do the other side, the same physical, maybe a smaller scale version of it, or maybe ideally the accurate, full scale version of it. You want the digital twin and your physical hardware to be 1-to-1. So if you're going to do a small scale, you're going to do the small scale too on your digital twin. You don't want to do something big and then something small. Keep the sizing the same, but you're going to take 1,000 samples and you're going to do a blind test. So what you're going to do is you're going to do a sensor and give it the same external triggers to actually conduct the experiment. And over the 1,000 trials that you have, what determines whether it's good or not is the accuracy that you've done in those blind tests. Once you compare them, do they both reach the same destination? Do they both reach the same outcome that you would have expected? And they would have not known or even interfered with each other at the end, right? Or throughout the experiment. Hope that makes sense.
We can ask one more question before we wrap up. Right here, Nin.
So on the topic of AI and smart cities, I was wondering to see what are your thoughts on how we can make our city more cleaner and homeless people off the streets?
Who wants to tackle that? That's a very San Francisco question. Ken? Since you live in the city.
I'm trying to think how we accomplish that. The only thing I can think of off the top of my head is I developed Genius AI to actually go global and allow people to use their phones, and a lot of the homeless people have phones. And what that can do is that it can help with the swarm AI, but they actually get paid for us using their phone. And then, like, we were planning on doing this in Nigeria, where we would give them all the AI, they would earn tokens that are on the blockchain, and they can turn those tokens in for cash and then go to the doctor, for instance. And so it's kind of an income-based thing for them. And so, I mean, on the cleanup side, I mean, if the homeless are able to, go to the doctor or get off the street or get into rehab because they have a little bit of money and they can eat and stuff, then it helps. But I don't know about, cleaning up trash and stuff like that. I don't know how AI could be involved in that necessarily.
I'd like to add one quick sentence. So I see this as more of a duplicate, like a dual economic political thing or financial thing. So, but then there's another side is if the resources are granted by some programs or some government agencies to be able to do this, what type of technology would apply to it? Well, there's opportunities. For example, with what we do, we create wearable devices or interfaces that enable people to control robots anywhere in the world. So things like virtual photography, virtual videography. Somebody could be remoting into a different place and doing a job remotely, and that enables more labor, more workforce, more people doing their thing, right? That could be a very real possibility, whereas in the past, if you need to go to a job, you had to be there in person. So, but given that it's a dual question, so that would also need governments to address those types of programs to make those things in place to get people actually off the street. So it's actually a dual question, but I think that's how it could be applied.
And just adding to that, I do feel that the government budget could go like each dollar can travel a longer mile if we had robots building mini houses, right? We're talking about tiny homes, etc. Of course, when a lot of you own your houses here, or even if you don't, you probably know how expensive it is to own anything in the Bay Area. And more than the cost of the material, it's the labor cost. Now, I know that robots would also be taking away jobs when they start building all of these houses, and it's already happening on the factory floor, to be honest. But it also makes the price point very accessible. And then, if the government today can probably fund 100 tiny homes, in the future with robots building these houses, they might actually be able to fund like 1,000 tiny homes with that. We don't have time for any more questions though, but what I'd love to do is just ask each of our panelists, just take 30 seconds, closing remarks. What do you want to leave our wonderful audience with? And also, how can they follow you and your journey? So I'll start with Navchetan again.
Sure. So my message would be that digital infrastructure is the key moving forward. And what he just asked, smart cities or clean cities, that's exactly because cities do not have enough resources to spend on the welfare, but rather they are putting all this on the infrastructure, like hardware-based signages and other infrastructure. So if we go digital, all those new revenue and the capex and the opex that the cities can save can put in the resources for the welfare of the residents, right? And please follow us. That's how we help cities build digital infrastructure. We are YCurb, short for yellow curb. So ycurb.ai. So please follow us there.
Thank you, Navchetan. Dominic?
Right. So, with my company, Gyropalm, we created, patented gesture-controlled wearable devices and actually human-computer interaction. So we have wearable HMIs, human-machine interfaces that enable users to control robots, autonomous robots, and training. So with the advent of physical AI and humanoids, we actually have, a patented framework that enables users to control fleets of robots anywhere in the world. And ideally, this is keeping people in a safer distance, hands-free, being able to do this anywhere in the world or 3,000 feet. We actually create also not just that, but autonomous mobile robots ourselves in the Bay Area. So if you are doing any factories, have any need for smart material handling, surveillance technology that robots roaming around, or even R&D, our team is here to help, and our team is able to deliver in a very quick and innovative manner to solve your use cases. But also the other thing that I would like to suggest is keep an open mind for what the future of AI and robotics can do for you. In our vision, it can actually indeed empower more people to have jobs and different types of ways to interface with technology. Because we integrate a human-centric design, we integrate a human aspect to this very heavily. So you can find me at our Gyropalm on LinkedIn or on YouTube.
Thank you, Dominic. Ken?
In general, Genius AI was started in 2016, and it stands for the Globally Networked Ultra Smart Artificial Intelligence. And to their point, the digital infrastructure, that's exactly what it is. And I thought about one more thing about your question, was that we're not actually there to clean up. What we're doing is trying to prevent further harm. Right? And if you're building these massive data centers, then like he said, we don't have any OpEx or CapEx that we have to build. We're using existing stuff. And so we don't have to build new stuff and use the water supply. And this is where a lot of the money comes in from taxes and stuff like that. And so the cities are trying to get that into there. But we're trying to, preach out there really of, hey, you don't need all the centralized servers. There's no need. And our technology, once finished here in the next couple weeks, will prove that you do not need big centralized AI servers. And so, most people don't. It'll still be useful for enterprises who want, secure and off-site type of stuff. But for everybody else, the cities, you won't need it. So follow us on gnus.ai. The parent company is called Genius Ventures, and that's geniusventures.io. And we have a venture studio that basically funds this whole arm of swarm intelligence type of things. So.
Thank you, Ken. And again, shout out to our lovely audience here. So let's just give a round of applause for everyone in the room, including our audience. Thank you, folks, and I hope you enjoyed the conversations. We'll take a quick picture here, and then we'll be out of your hair.
All right. thank you.
Thank you.
Thank you, everyone. Folks, you have to bear with me just for a couple of more seconds. We want to quickly talk to you about what we do as the Future of Tech. Ken and I, we are, I would say, like, kind of the founders for that. So this event that you guys are attending, and I am very grateful that you all could have been anywhere today, but you chose to join us at this beautiful venue of Circuit Launch. And this is probably, I don't know, like our 50th or 60th event that we're hosting here in the Bay Area. And globally, we have hosted over 100 plus events. And our community is 100,000 plus strong. We have generated over 30 million media impressions. And all of this is really because we have a passion for bringing the community together. And we have benefited a lot from introductions that were made for us by other people when we attended such community events, right? So you can look at some of our platform metrics. I already spoke about a few of these things. Between the three of us, we have actually, so there are three entities that make up the Future of Tech. I'm the founder of Orbis 86. You have Ken here representing Off-Chain, and then our media partner, Brand PR, that sits in the Middle East. We have hosted over 600 plus events globally, covered over 80 cities, and you can read the stats out there. That is our audience breakdown, people who usually attend our events. And this is for anyone who wants to partner and host an event with us. So this is why I'm sharing this information. So if you go to the next slide. The kind of events that we usually host, we have panels like the ones that you attended today. We also have pitch events, and sometimes they are open pitches, some other times they are competitions. We also have round tables and private dinners, and those are more curated events to bring together the right kind of audience. And finally, we just have fun networking mixers where people come, run into each other, enjoy a few good drinks, get buzzed a little bit, and then head back home. Usually our events are 4 to 8 hours, and we have anywhere between 100 to 500 attendees for these events. But for 90% of our events, our crowd is like 100 to 200 attendees. So if we go to the next slide. If you're looking to partner with us, please scan that. That takes you to our sponsorship and partnership deck. But if you are a startup or an investor or an enterprise looking to reach out to the right kind of audience, and especially in a community setting, because again, all of these events that we host is really to bring the community together, then please reach out to us, and we'd love to explore how we could work together, whether it is you sponsoring an event like this to bring the community together, or if you have a venue that we could use, we always appreciate that for sure. In fact, even if you can provide food and stuff, that makes us very happy. All right, and I think that's about it. Well, besides joining us as a partner, as a sponsor, another way you could join us is either enrolling as a speaker if you have something nice to share with our audience, or you could come and also volunteer for these events, because we really rely a lot on volunteers. Like right now we have all of these wonderful Swiss students helping us out at the event. So if you're interested in speaking or volunteering at these events, please check out the page. There are a couple of different forms. Fill out the form that's relevant to you. And with that, guys, again, thank you very much for joining us here today. The event is not over, but I'll be going back to my AV seat. Again, I'm Sonia. I am your host along with Ken today. And thank you very much. Thanks to everyone for coming, and I hope you all enjoy the barbecue later on, so thank you guys. And with that, I'd love to invite Ken to introduce our next panel.
Usually as MC, I would make commentating and things like that, but because of the time, I'd like to hand it off to Mark, our moderator for the Fireside Chat. We have an amazing speaker here, so Mark, I'll hand it off to you.
Hi, everyone. Welcome. I'm Mark Anspink. First of all, I did bring a sport coat, but I was told it was really too hot to wear it. So for the record, I did dress appropriately. As I said, I'm Mark Anspink. I'm the managing partner of Kylon Ventures. We're a full-service venture platform, and our focus is we work with Vietnamese founders here in North America, and we help them in anything. I have worn an apron and helped sell chili sauce, to help sell sponsorships to national conferences and everything in between. My wife is a refugee from the fall of Saigon, if you're questioning that connection there. Today we have a really interesting discussion. Unfortunately, one of our speakers is at the mercy of 101 or 280, and he is stuck in traffic. So Dhruv will not be with us today. But you're in the more than capable hands of my guest here, Anu Ramraj, who's the founder and CEO of Vaultsy, and is also the author of When Robots Knock. You want to take a minute or two and tell us about yourself?
Happy to, Mark. And Mark and we were talking about this speaker who was stuck, and we almost pulled out a robot from there to come and sit with us, but we weren't sure what the robot would say. I know it dances really well, so we decided against doing that, Mark, did we? Yeah. Yes, okay. Anu Ramraj, as Mark said, founder and CEO of Vaultsy. So we're building an AI life assistant that knows about you through your documents, your most essential documents. Think about your birth certificates, to your medical, to your legal, to your financial, and then assists you through life's milestones. That's what we're building, a life assistant. And prior to that, I was a partner at Pricewaterhouse and about 2 decades in the industry, global leadership roles, Hewlett-Packard, Unisys.
Thanks so much. All right, we'll dive right in. The first is the concept of the one-person unicorn. There's been a lot of discussion about AI making it possible for an entrepreneur to build $1 billion company with very few employees. But do you believe it's actually possible for the one-person unicorn? And if so, what sector and how far out are we going to see that?
Wow. He wants the sector too. All right. So maybe we'll start with a poll of the audience, Mark. Let's do it. Okay, how many in the audience think that the timing is already here now for a one-person unicorn? Okay. I think it's still the minority, Mark. So that's the popular opinion. And the founder of Anthropic, I think he said, 70-80% chance that we're going to see it within the next year or so. That's the founder's opinion from one of the leading models. But if we dial it back, right? What does that represent, a one-person unicorn, right? I think the way to look at this is that I think there's never, ever been a better time to be an entrepreneur, right? Today, you can do the full cycle of work that you need to do for building a startup using agents, and with all the way from a coding agent to a marketing agent to a HR agent, name it, right, to a legal agent, right? So no more are founders trapped in this loop of, hey, I have to find a VC so I can actually keep this sustainable. As long as you can find a few $100s to pay for your agents, you can be building and marketing, and that is so fantastic, right? So forget the one-person unicorn. This is the best time to be an entrepreneur, right? So I think everybody should just be seizing at that moment and just grabbing onto that stuff. But thinking about that one-person unicorn, right? I mean, we've already come really, really close. I mean, like everybody talks about the Instagram story. What were they? They were acquired for $1 billion. They didn't have a lot of revenue, but they were acquired for $1 billion, and they only had about, I think the saying was about less than 15 employees at that time, right? So again, that was like what, 2012, 2013. So that was already pretty close there, right? $1 billion acquisition, right? And now I think there was like another one that was out on the street, Medvi, that got to like 400 million in revenue, had one founder and who did all of the work, right, including the development, the marketing, etc. But they were selling GLP, which is a different thing, right? So I think it's definitely possible, and I think we're definitely going to see it. Is it the right thing? Is it the greatest thing for society to have these one-person unicorn? That's a whole new angle, Mark. Yeah.
I was going to ask that as a follow-up question, so we'll make it really quick. Is it good that there be a one-person unicorn? During COVID, I mean, everyone got tired of sourdough and Ted Lasso, and they wanted to go back and be with people. So is it a good thing or a bad thing that we possibly could have one?
I don't know. What do you guys think? Good or bad? If you think it's good, raise your hands. Do you think having a one-person unicorn is going to be good? okay? Okay, people, it's still
All
a
right.
minority,
Okay.
yes.
We'll move on.
Yeah.
You've talked about, you and I obviously prepped, and you mentioned what was a really interesting term to me. It's the human premium. At a time when almost all the buzz is about what's going on out there. It's AI. It's physical AI. It's faster, it's cheaper, it's more reliable. But is it more valuable than people? And if so, how?
So the human premium, the way I see it is like when we get those robotic answers on the phone, if you call in, how many of you try to look for the kill switch? Like all of us, right? Like the 0 or the 9, I need to talk to the human, right? That's the simplest explanation for the human premium, right? And yes, today, I think Bill Gates was out there saying that, I mean, a PCP could be replaced by an agent because it's fed it so much information that that it passed the USMLE examinations, the medical licensing examinations. But are we ready to walk into that PCP office and have an agent be that, do that job? Probably not, right? So that is the human premium, right? We still want empathy. We still want human judgment. And those are more valuable than ever, right? And the companies that invest in it are investing in the human premium and are going to be super successful. The companies that say, hey, just because I can do it with an agent, I'm just going to take the human out of the loop, I think they're going to be less valuable.
Okay. I mean, this was completely random, but when I was driving down here this morning, there's a credit card company that brands its various tiers using valuable hard minerals. And their whole ad was about the fact that you got a live agent when you called. They said, what differentiates us and why you should use this Premier card is you get a real person on the phone instantly.
There you go.
So you paid extra for that.
Yes.
And that kind of sounded appealing because recently I was in Vietnam, there was a typhoon, and next thing I know, I've got to figure out a way to get back to the US. And let me tell you, the chat did not help.
Yes.
And it was a panic, and eventually I did get a live person, and then we got it solved.
Yes. But believe me, the agents are going to get better. They're going to speak more languages than you, Mark, right?
Yeah.
So that's going to change, right? The agents are going to get better and better, but I think there's still the human premium as well.
So, as I mentioned, you wrote the book When Robots Knock, and you co-wrote that with your daughter, which is a whole other discussion.
Yes.
But you interviewed 25 leaders across a range of industries. I would like to hear what were some of the different perspectives, what were some of the biggest lessons, and what were some of those aha moments that you discovered in those 25 conversations?
Absolutely. So we actually picked up 9 different industries, right? And we spoke to experts, and they were not just in the US, so they were global experts across these industries, right? So we didn't want just a tech view, right? We really, really wanted that industry view. Like, what do the folks that are hardcore educational in the education field think about what AI and robots will do to that field, right? What do the people that are hardcore in the healthcare field really think about it, right? Like, so these were like the real experts in each one of those industries, right? Whether it was cybersecurity or legal or medical or education. And then what was surprising is that there was so much commonality that was emerging across these industries, right? And the human premium was actually one of them. And then I'll touch on like 2 things that really, really stood out for me across these. One was learning cannot be front-loaded. Like the pace of change is so much. Like, we asked these experts in the book to predict how will your industry look like in 25 years from now? And they were all like, oh my God, I don't know whether we want to go on print saying this because it was just so much change, and the rate of change is just so unpredictable in some ways, right? Like, there could be a fork in the road where we could have AGI, and then that could completely change stuff again, right? So one thing is that we all have to adapt as we go and pick up new skills as we go. So learning cannot be front-loaded, and we got to be constant learners. And the same goes to all the founders, right? So yes, it might be a great idea the moment you're implementing it, but then you could get quickly disrupted by somebody else. So which means, yes, you have a big advantage that you can build it quicker and cheaper, but then the VCs are worried that you'll get disrupted also quicker and cheaper, right? So that's the angle there. The second big angle, I think, was around regulations. And consciously, I think regulations are going to lag behind technology, right? I think Europe has passed like an AI act saying that anything that is generated by AI has to be marked clearly. They have already passed an act that says that AI algorithms have to be ranked based on risk, right? And there are certain things that are high risk that are like, that you just cannot do. I think for the US, I think we took a conscious approach where the federal government says like, we don't want to stop innovation. In fact, they said that states should not be doing their own acts around AI, right? So this is like nuclear and cloning and all of those, like the regulations are going to come later. And so the companies, the founders, actually have to watch out, right? So you have to be responsible even if the laws don't exist, right? Because if you lose your user trust, then you can never rebuild that, right? So even though the regulation might not exist, you as the founder have to like kind of watch out for your users.
We could have a whole panel on just the regulations and the legal aspects of AI. I have a very good friend who's the compliance officer for one of the largest private equity firms. And it is just, they're making up as they go.
Yes.
So with that, we want to hear from you. So anyone in the audience have a question for us? We stunned them.
I think everybody's excited, getting ready for the barbecue.
Okay.
No, but it's an amazing conversation. Actually, if I wasn't the MC, it would have been great for me to join you in this panel because workforce development is my background.
Okay.
Awesome, awesome.
So thank you.
So in the nature of, or in the spirit of keeping things, getting the train back on schedule, why don't you just take 30 seconds and share the one thing you think the audience should know before they leave?
Absolutely. If you have high school kids, especially, I know the reason that we wrote the book was because my daughter and me were, like, we're co-authors, but we were debating, like, how do kids even choose a field, right? When things are changing so much, so I would ask them to kind of explore more, read the book or find an equivalent book because it's, different fields are morphing at different rates, right? So it's a great time, but it's hard, it makes it also hard on the kids, right? So that was one thing. If I can do two things, Mark, YZ.ai, that's a piece of, that's our product, VAULTZ.ai. We're live on the App Store, and basically we are an AI assistant that knows about you through your documents. So feel comfortable to upload whatever you feel comfortable with sharing. We guarantee your user privacy, and we stand behind that, and we would love for you to check it out and send us feedback. Try it out. Thank you so much.
Thank you, everyone. Have a great afternoon.
All right, Mark, I guess we post. Thank you. Thank you. Thank you so much. It's yours.
All right, next we have a representative from AMD. This is going to be one of our closing presentations, right? Jerry's going to be, he's got an amazing presentation without the slides, so I'm going to hand it to Jerry to introduce himself and talk about the presentation. I'm going to grab the crowds to come and hear your final presentation.
Very good. Welcome. I'm Jerry Wong, and I'm an AI visionary. I talked at CES in 2014, and I showed 2 demos, and both of them became funded, but not just funded, but both of them became monetized products today. Okay, so I'm thinking, looking out on the floor, I see some things there that look like money to me. Okay, there's a few of them. I'd like to mention the nosh cooking demo. Okay, that looks like money to me. Okay, there's going to be butter chicken starting at 5 o'clock, so go check out Amit. Okay, second one is UBOTBox, URBOTBOX, and that's a construction helper. That's one where the one that brings all the bricks and the mortar and the tiling material to you. and also brings you drinks if you wish. And this is something that also looks like money. It does the things that the workers don't want to do. So check out Will, who's in the back. And also the third one is Smart OS. That's like Smart OS except with an I, SMAIT-OS. And what that allows you to do is it allows you to have communication between robots from different companies. Okay, it's a really very nice idea because the robots that know things can share with those robots that don't know things and make the whole network smarter. It can do dispatch, sharing information, mapping. Also, if there's like a hazard area in a hospital, perhaps, then it will avoid those and be able to route people smartly around that. So we have the CTO sitting right here, the marketing right here, sitting over here. So come talk to them about their concept. It's really quite cool. So people have asked me about how is AI doing? Okay, AI is doing fine. Okay, and there's 4 useful types of AI that have happened in 12 years. Think of that. That's every 3 years is a new type of AI, and we have our inference, our generative AI, our large language models, and our agentic AI. And at this pace, I don't think it's going to stop. Okay, so we're having roughly 3 years per new type of AI, and they're all ones that complement each other. But there's also going to be some things that are enabling technologies, and I'll talk about those in a little bit later about that. I think that AI is now being monetized largely through productivity, which is a good thing. There's some companies that keep all their workers even through this, and what they do is give them additional tasks to do. So at AMD, I am actually here because of AI. I was actually overloaded, but it's given me extra hours per week, and so I'm here because of that. There's active competition between on supercomputers, active competition between companies and also nations on supercomputers. So this is one, don't sleep on this. You know, check out on Wikipedia, you know, the supercomputer top 10. You can see it's pretty split up. It's really fantastic. Okay, this is one where there's a lot of people that are dedicated to actually being involved with that. Now, what about robotics? Okay, so I'm encouraged by the technologies of robotics that are happening now. One of the big ones is the Ukraine and Russia, the conflict, there were drones. Okay, this is something that is, you know, if anybody can leverage that message and be able to let people know it's actually here, that's a really good thing, really good data point. Now, cartoons and movies predicted something different. Okay, they predicted things like the Transformers, and it hasn't turned out exactly that way, but they're definitely here. Okay, so what is it that we've learned from that conflict? Well, we've learned that robots versus traditional arms like tanks and aircraft and ships, that's a real thing. And also, there's the idea of economies. Okay, so that's an economic shift as well in the robotics. Also, small but many. That's a real thing as well. So think about possibly, instead of having one robot do the task, you know, have a swarm. Think about that. It's hard to stop. Defense is also a new market, being able to defend against things like this. And not everything has to do with military. Okay, so in general, you think about the jobs that are dangerous. Okay, there's commercial jobs that are dangerous, and so we can think of that. It could save lives. The role of the hobbyist, really, really huge. Okay, this ought to encourage a lot of you and us, because you know a lot of the really good ideas are coming from very small teams. Okay, we talk about the unicorn, the one single contributor. Okay, and this is something that's real. Okay, there's taking existing platforms of drones and also existing platforms of tracked vehicles from, you know, hobbyists, but also from agriculture. Okay, this is something that's real, and it's the history is repeating itself. Okay, if you look back in World War I, there was, airplanes and tanks was a little bit homebrew at the beginning, and they came from things that were, the tanks came from agricultural vehicles. Okay, so there's a little bit of a history. You can learn from history and see where that might lead. Also, the hobbyists armed with 3D printers. Okay, that's very cool. And computer hobbyists that have technology. And it can be just small groups. Also Starlink. The Starlink was allowing people to stay connected, but then also the latency requires that there's local intelligence. Okay, so maybe through waypoints. So you can help create the robotics market by leveraging this huge event. Okay, and think about the things that is the facts and the energy from it, and give it to commercial applications. Okay, so this is something that we can do, and then definitely try to monetize it. Think about how you're going to get money in the end for it. Have it do the jobs that are dangerous, do the jobs that nobody wants to do the jobs that are mundane. And then there's also other values, and these can be social values. We'll talk a little bit about that. There are other technologies that are also good besides Ukraine and Russia. AI. AI is a gold mine for leveraging it into robotics. We met the guy here that coined the term physical AI. So if you see a guy named Jasmeet, give him a tap on the shoulder and ask him, how did you coin the term physical AI? Okay, but he's here. Many workstations are here as well. Okay, great tool for robotics. And when people want something that's embedded, they want to have a long life, like 15-year life on their product. So they're looking for an inflection point in the jump in the performance. That time is, one of them is now. 3D printers, printing, laser cutting, home business, prototyping, invention. Parents can buy it if they're easy enough now. And they're not that expensive. So you think about what used to be a shop class, like a wood shop class. I mean, you're enabling a virtual factory now. Blender, okay, so this is a tool. And the thing is that using AI, there's so many new features in Blender, it's really hard to keep up. But AI can actually teach you how to use Blender, these new tools. Okay, so it goes around. Bringing some manufacturing back to wealthy economies. This is something where, people can prototype, people can make things in, wealthy economies, and then wherever it goes for the factories, so it goes. And it can be in a wealthy economy if there's enough leverage for it. If there's a robotics wood shop in school, there's a possibility of having servers. Educational don't want to have children give their information out in public, for privacy. So having large language models run locally, okay, in a server in the district. Yeah, that's a real thing now too. And then you can have a limited amount of hardware, but the robotics hardware can actually be running in a simulation. Okay, and this is something that we've seen in certain camps, robot camps, where they don't have to buy the hardware of the robot, but it's running in a simulation that's strong enough that every child has, access to really elaborate robots for their projects. And then you can have positioning, like global positioning. If you have local beacons, it's down to the centimeter accuracy. Okay, so think about this for, outdoor applications, whether it's agricultural, but also indoors as well, okay, if you have a location. So one of the things, I'm going to finish it with two questions that I've been asked that were both tough questions. And one of them is, what does the future hold? Okay, I'm going to talk about AI, but I'm also going to talk about robotics. AI, more types, okay? So we have those four, okay? And the enablers is similar to what we saw in computing. You had computers, and it was enabled by spreadsheets and databases. Okay, it wasn't a new computer. It wasn't a new computer type, but these are things that unlocked huge, huge things. And this is where I think AI will also have some enablers, and then there will be significant, very significant. More monetization of AI through productivity, I think it's not going to stop. I think that people will learn a little bit more how to use them, and we'll just get better and better at it. There's going to be a taste for finer implementation. There's a lot of things are running on CPUs and GPUs now, okay, but there is actually higher performance and lower power and lower cost versions, but they're, kind of difficult to program. Those are neural processing units. Every core has to have its own program. So you're looking at 400 programs. That's a lot of work, but the payoff, okay, is performance and power. Also, another one is FPGAs. It's like designing a chip, which is even more difficult than programming an NPU, but the performance is even better than that, okay? And also the power is even less than that, and the cost can be very good as well. So these are areas where, as the taste for AI gets to be a little bit more elaborate, then there's going to be a moving towards more and more difficult designs. People will want those. Okay, so this is something that I met some educators. This is an area where education can be biased and move towards these things, these technologies, and some, not just young people, but some engineers may add some skills and learn FPGA design or neural processing unit design. Okay, we have there's AI PCs that are out there, not doing very much with their NPUs. But 20% of the high-end CPU processors in laptops have NPUs that are significant performance. If you look at autonomous driving, that's 37 teraops. There's laptops that have 50. Okay, and what's it doing? Not much, just eye contact and things like this. So it's a great opportunity. Let's see. Better tools. Okay, there's not going to be enough engineers. Already, there's not enough engineers that know FPGA. I mean, there's groups that are saying we have got 4 divisions. We've only got 1 group that does FPGA. Okay, we just can't hire enough, and there's been job openings out posted for longer than a year. Okay, so it's going to get worse as there's more need. Okay, that's future. What about the second difficult question, and that was, how do you get robots to be accepted socially? Okay, and so the humanoid form factor is an obvious choice because the world is designed for humans. Okay, but let's not limit ourselves to that, because similar to the way that when the cell phone came out, the concept was the Star Trek communicator or the Dick Tracy watch. Yeah, StarTAC or the iPhone, the Apple Watch, those are real things, but it wasn't the majority or the first real solution. So let's not just think about humanoids, okay? Humanoids will be, because labs, things that are, remote locations like space or, cold locations, they will be a real thing, okay? But to be able to interact with humans, there might be better form factors. I saw a little robot, a cute one out there. Okay, it's things like this. And so there's some form factors that allow the robot to do more than a humanoid would. Okay, and so think about those things. And if a 350-pound robot, it can be a little bit intimidating. And people expect a human personality and say, well, it didn't say excuse me, okay? It seems rude. Okay, well, if it's not a humanoid, it doesn't have to have those personalities, right? And so considering using spaces that are not used by humans, okay? So, and that would be, if you're in a business, a different checkout line, maybe one that goes to the back of the store, one that flies, okay? One that's hovering by a helium balloon, one that's attached to the ceiling, okay? Or maybe even on a track on the ceiling, okay? So these are things to think about, you know, and there can be some advantages of having something that doesn't fall down, okay? They're considering using the centimeter positioning and Starlink, accessible shopping, touring, not having to travel to the location, but just being with your family there, okay? Hiking trails. Let's say that there's somebody out there and they're able to wave down the drone. Honestly knows that somebody's waving it down. It's close enough that you can communicate calls. Okay, so here's a good one. What about a gift bot? Okay, let's say that there's a wedding or a birthday or maybe a funeral that you can't make it to. Okay, and it might be something that you can't make it to, or maybe your flight got delayed and you can't make it to suddenly. Well, the refund of $2,000 for your flight and your hotel, that can go a long ways to making things better. If a gift bot shows up in line, and that's, you know, virtually you with, you know, with a meeting, right? And they know that it's a gift bot and it's bearing $1,000. You know, they kind of go, yeah, I'm glad you're here. You know, glad that, and this is something, right? And so, and then consider a robot having to wait in line. Let's say that the line is long. That's ahead of you. Okay, is that going to be acceptable? Okay. The form factor, like somebody sitting in a wheelchair, okay, and you think, okay, well, you know, and there really is a person somewhere waiting. And that's kind of acceptable. You talk to it and say, hey, you know, yeah, it's been a long line here, okay, and then that's acceptable, okay? How about a humanoid robot sitting at a computer? What if you eliminate the robot? There's enough smarts in the computer that can simulate everything that the computer sees or does. And so you've got your CPU, you've got your GPU, you've got your NPU all in the computer. Why not have a second model where you don't have the robot sitting there, but it's fully automating a task, okay? Right? Winding up, technology is changing fast. And I'm Jerry Wong. I hope to see some of you all next year and in a different and better world because of the decisions that we make today about robots.
Thank you, Jerry. That was a very meditative speech and final presentation. So we're going to have Deepak come up. Definitely, he's staying behind, right, Jerry? To ask him some questions, and I really appreciate him spending the time. And Deepak, there you are, right here. Let me get your presentation set up. Let me pass you the mic. Okay.
If you have a chance to talk. How did you like it? Overall, very Robotics
in the same directory is
TPU? Yeah.
So, yeah.
Are you related to the expert engineer? No, we are. I am okay.
we go. Sorry. Last slide first. Okay. Thank you, and Jerry, very nice summary of the whole day and future. And I'm glad, we are meeting first time, but you will see I agree on many things with you, and it's coming up. And I was also surprised to see that you have Jerry from AMD, big corporation experience. I'm a startup guy. So, and pre-seed startup guy, right? So, but they have done a thing so startup is I'm innovation-driven startup guy, future-driven startup guy. So, and then think about it I'm old guy, like Jerry, coming out of retirement startup guy. So that's my, I've worked at NASA and done my good work and well known in certain fields and so on. And but then time to time, actually few years back, that's what my story is. During COVID, my family, I have only one daughter. She has grown up. She's a lawyer, and my wife both work. They say, you just retire and take it easy, do gardening. But then I started to see the problem in the AI and robotics and so on. And some of my friends have said, oh, you are too intelligent to retire too early. So I became a startup guy again, and this is what it's about. So I'll talk a little bit about the future. So one of the things that we match, and actually Jerry was alluding towards, is that one of the problem of the which I call as big AI, right? High power and high resource consuming, and whole sessions are devoted, infrastructure and everything is needed. So someone has to worry about the future, and they say power you need so much that it will consume. Coming out of retirement, a startup guy, let me address the big. I'm not the thinking in terms of the distributed, decentralized, which could be analog AI. So it could go a million times less. So, but before that, I'm still stating this statement in terms of problem and solution. So problem is big AI cloud, whole thing is not suitable for physical AI at the edge. All the robots, drone devices, these are edge devices. And if we can do it on the device itself without connecting back to for everything, spending tokens and doing that, for future, no, some of the big enterprise thing, great, but for distributed and AI, you don't need that, right? So that's the problem. Physical AI, robots, drones at the edge, that's the problem. Because it's a monolithic big AI, it resides in the cloud. So, okay, so one way to think about biomorphic intelligence, which is where that's what even the big guy realized, that they are moving from 2D video data to 3D sensing in the real world, which is huge data which they are facing now. So if we solve the toughest problem, at least allude towards that, then we are going towards the solution. So what he's saying, so our basic hypothesis of which we realize that biomorphic system, data is broken, incoming sensing data is broken. For example, enormous amount of perception sensing data is generated at the edge, but 95% of it is redundant. How useful it is. And biomorphic system of the sensing perceives the data, but ignores most of it and only pick up the important part. So event-driven and selective data. That's what we are talking about. So in that sense, and if you address that, you gain a lot in the terms of the efficiency. So, and this is not a minor bug. This is really a fundamental architecture problem. So I said, okay, during COVID days, you're sitting there and saying, how will you address that problem? So I said, okay, innovation. Think small AI. How do we do that? So one is, let's try to tap into the energy efficiency of biomorphic intelligence, which is like all living beings, right? We know that on Earth, most intelligent system at low power is living. So why not we learn from that and pick up something small? So first statement, tap into energy. Biomorphic intelligence is analog AI. It's not digital. You have to. So these are basic. That gives me the basic part. Neuromorphic. And then second is think small, build bottom up. Nanotechnology was my expertise in NASA, so I'm bringing that nano AI, right? So build bottom up. So what is the bottom? I went back.
fruit flies, bees, they're pretty intelligent. Can I build my basic building block unit from the intelligence of bees? That's the question I ask. Yeah, so okay. So look in the biology literature. I'm a quantum physicist. I can jump into any literature and get the essence of it and then collect a team and start build it. So think a small, build bottom up intelligence of bees and insects, and then make it massively modular. If we make a small AI, and really start to scale up like everyone else, then we will also run into the same problem. So then we think like Lego blocks, building blocks. Bricks are smaller, we can make big building and employ the efficiency. So these are the things, and these are not just the concept. Now, right now, it's a 2-3 years of work, and I have a 7% team. That's what you do in the startup thing. So as a sensing, like you see, so we have a perception native, and that's the name of our software, Earn AI software, which is built of AI kind of Lego blocks, very small units. And it's a kind of a plug and play kind of stuff that in the current camera or vision sensor hardware, it's you don't have to change anything. And entire hardware stack remains same, and you can use our software. It can convert the digital into analog, do the AI on that, and still give you the result. I'll show you the demo. So Earn AI software like AI Lego block, no need to change anything. This is the example, that's where the saving comes in. So for example, this is an, I have this image is done by, I have 6 beautiful, not beautiful, 6 very smart and intelligent interns from Switzerland. They just finished a 6 weeks course, and this was done by one of the group. I have 2 teams. That's how, this is again, I'm an old guy, but I still do really lean and all those bootstrapped AI, bootstrapped startup. So you see, conventional frame-based vision, like you have a video, right? Digital video, frame. And that's where the inefficiency is. All the video camera, if they have that, the CCTV camera, they observe everything, record everything in the cloud, and you have to go. A lot of inefficiency. They are not biomorphic. Biomorphic is also observing, but it will record if something unusual happens, if that is the purpose. So that is where this, you convert it to analog, and on the right-hand side is event-driven vision. So you have really ignored a lot of the data, converted into spikes, really like a biological systems, like you can say, and then you are doing AI on that, so, and this kind of works. So having said that, let me show you the demo, and then we show you. Demo is a video, so I had to close this, but then, yeah, okay. See, I have to again take it off because okay. Oh, I got the, and then I'll put it on once I open the, okay. Got it. Now you got it back again, yeah. Yep. Let's see if it comes in. Yeah. Okay.
Now it's on this side.
Yeah. Okay. Yeah. Right. Oh, okay. Yeah. If you just leave it there.
Welcome to New AI. Current big AI models are not suitable for edge or extreme edge. New AI introduces massively modular, evolutionary, reconfigurable, neuromorphic VR and AI software. From the neurology of honeybee's vision system, highly efficient, individual, small data trained, analog AI modules or AI Lego blocks are developed. Software is a real-time configuration of many such AI Lego blocks for a given application. Like the building blocks or bricks of a building, ER and AI Lego blocks are build them once, use them again and again for different applications. For example, event-driven and selective cameras. event-driven safety and security monitoring day and night, rain or shine. ER and AI software for motion detection and classification, day or night with no IR sensors. For example, ER and AI software for event-driven sensing, alarm and recording, day or night, rain or shine. ER and AI software for 3x3 AI Lego block array or neuromorphic edge sensing arrays analysis of a higher resolution video, analysis for motion detection, classification, changing the resolution, and focusing of a video analysis using AI Lego blocks array configurations. The various arrays show the capabilities of neuromorphic AI analysis of HD resolutions without increasing the workload. Here is the compute load saving in the training and inference of a 10x10 AI Lego blocks array configuration. The overall compute load or energy saving in both cases is around 500 times better.
Okay, you were here. So you saw the example of the POC concept of event-driven, but we can do, because it's a modular thing, that's the advantage that we can really focus on this block is active and this block is inactive. So we can do like a human biomorphic system of the vision. And vision is the most toughest sensing signal. Audio and everything is a little bit simpler than that. Just believe me at this stage. Okay. Yeah, okay, enough time, yeah, no worries. Okay, so this we have done. Okay, so that's the demo, but we did like, this is very fresh off the like a press kind of work. Just in 2 weeks back, we did, because we have started to show this work to VCs. First thing they ask, have you done any benchmark? So I go back to the team. So we did benchmark and so on, and we just checked just the published result, not the commercial software would be different, but some of the Google or Facebook, people have a university professors appointment, so they publish. So this is, and this is especially the edge model. So it shows you a number of parameters. So you see top two is a Google, next FAI. FAIR is the Facebook AI research, right? And they are 25 million. So these are not billions of parameters. These are small edge models. And at the bottom is our Earn AI 3x3 array, 18 million kind of thing. So you see that even, and this is our unoptimized raw code, and without any optimization. So first we just did it that this is 37 times better than the Google and 12 times better than but the transformer is the key one, because transformer is underlying all big AI model, right? LLMs or LVMs. So with transformers is I would not say so inefficient, but our unoptimized is 78 times better than efficiency is better than that. And so, and then just to test ourselves, because that's what my basic, these are basic premise. Can I take it to the laptops, right? Which is what Jerry was saying. There's a lot of CPUs and this thing is sitting there, right? And that's how, if I can take it to the even low, not low level, but low end laptop, basically I can distribute this kind of an AI. So this one, then we did, this numbers are done on an unoptimized code on a Asus 16 CPU laptop of one of my guy, which is 1922. So these numbers are, so now we are moving it to some really specific edge hardware from NVIDIA, and if I work with Jerry, maybe of AMD and all those things. That's what I need partnership. What they mentioned, I need partnership. I got the partnership from the Swiss students who did the website, because I think I'm doing something next level, so people will help me out. I'm always, yeah. Okay, so but here's the 3-year roadmap. Well, these two red ones we have already, it's totally bootstrapped company, not raised any money yet, and come to the demo, patent pending technology, and that's where, see, that's where you are again matched. You see that I'm mentioning, I will take this to FPGA, so I will also look for some smart FPGA designer. FPGA would be the key thing, because once I have broken big AI problem into a number of small AI problem, then I can do it in parallel, right? and FPGA is the hardware to go. So it was already there. So that's why I said many things you recognize correctly. We are going the same direction. But I would like to take this to really low power physical AI at the edge. Having said that, I will not get into it. Right. So this is partnership, and obviously, and I'm not. This is not a pitch, so I'm not telling how much money I'm raising. But yeah, I'm raising money. So if you're interested, talk to me. But this is not a pitch. This is a closing talk. So that is why. Let's go to the last slide. So near-term, so in that sense, actually, I realized. So top is the software part, and the bottom is the robotics part, right? So basically, you're already industry is moving. Some big guys, they have already raised $1 billion. I've raised nothing. So that's what the difference comes in. But at the end of the day, that's where I think message for all the young guys, or even others also. If you're doing a startup, you always have to think 4 or 5 steps ahead. Then only you have a chance of survival, right? And still, I'm not guaranteeing anything. I still will fail, but it doesn't matter. That's what your or my attitude is, right? So okay. So even at this stage, as we talk, two big physical AI or 3D world model, then there are 2D world model. What they are doing is like Google and Fei Li, and there's another guy, Lee Kun. So they have developed where they convert the 2D videos into the 3D, but it's still a projection. The problem that will come in is that they still cannot do the real 3D world model with the noisy environmental condition changing on the fly. Because robot, if it's working remotely, it will be working into real, which is extreme environmental conditions. So we need to address and go for the really tough problems. So this is this thing. So we will go. So blue is that we will be doing. So massively modular 3D micro world model in few years. Once we have it, we will go for that. And biomorphic. So one of my goal is this. For going for small is making it biomorphic training and inference both at the edge. Right now, industry, after all doing is spending, is still doing it, they are just doing inference on the edge. See, what does it mean? And that's where the token come in, and that's where the money and everything, people are already complaining about that is so expensive, right? So if we can address that, then we can really beat everyone else on the cost side also from the business perspective. So that's one. And the last part is, just give me 1 minute more, is on the robotics side. Again, I absolutely, and this slide again prepared, and this is also my view, same as Jerry's view, like a futurist is, humanoid robots are, I also believe they are kind of overhyped. For certain reason, they are good for certain thing, but at the same time, think about like humanoid robot, using humanoid robots, robotics to replace textile workers in China or diamond worker. It's not going to make sense, right? But then for space exploration, for mining, for fire track, and all those things, for extreme condition, yeah. But and the second part, which is what I agree. So space settlement with Moon and Mars missions. Some of my dark thing is for mining. So because I come from NASA. Another part is this. Why are we used to seeing that, or we used to imagining robots, right, like 2 eyes, 2 hands, why not 5 eyes, 10 hands? Or that's the form factor, Jerry, because the same thing. You have to think different, right? Because for a task, right now all our imagination is coming from, we want to make a robot like us, but why? There's no guarantee, right? Because especially even for space exploration, on Mars you will need a different form factor, on Moon you will need a different, and from somewhere else. Only if they find a planet, that's my ending statement, which has Earth-like condition, then only you will need, or you may need, human-like form factor. So you have to start thinking, and that I learned at NASA, that you have to break out of the mold and think out of the box. So then that's my ending
That
message.
is actually a really good closing statement. Thank you, Dr. Deepak, right? So it's an amazing final presentation, and thank you for sharing that. So we're just about wrapping up, but to get you all hungry and excited for the after party, we have a very special guest. I'm going to have Sean come up and introduce Chris Ye, and I'm going to go and get our party ready. But this is an amazing speech, amazing amazing fireside chat. So I'd like to give this to Sean.
All right. Is that mic on? All right. Perfect. All right, so for everyone that may not know, I interviewed Chris about a month ago. Some of the students were there for that recording, and we decided we have to continue that conversation. So with that, if you remember how that interview ended, we talked basketball. So Chris knows all the stats, and in fact, he recommended the most dominant player in the sport was Dennis Rodman, and that made me think probably more than anything talked about in that interview. So my question to continue that conversation is around the Lakers and what just happened, and how does that transaction, how does that relate to the startup ecosystem, correlate the sale of the Lakers, the dynamics of the ownership to Silicon Valley, startups, investors, all that jazz?
Absolutely. So for those of you who are unaware, because not everyone in Silicon Valley is a big sports fan, the Lakers were sold for the second time in a year. They were purchased, or at least they were announced to be purchased.
Before that, actually, yes. Chris, can you give your background?
Yes. Hi, so I'm Chris Ye, and most people know me as the co-author of Blitzscaling, which is a famous startup book I wrote with my friend Reid Hoffman. I carry with me to all these events these signed bookmarks. They're actually signed by me, like so the real Sharpie and everything. So I give them to folks afterwards. If you want one, you're welcome to have one, because I find that it increases the chances people buy the book. So it's a very, very helpful marketing tool. And in addition to that, I also run a venture capital firm called Blitzscaling Ventures. You may have heard of some of the events we run, like the Llama Lounge series around AI, primarily in San Francisco, but other places like that. And I am just so excited about all the things that are going on in the world. There's never been a better time to be in Silicon Valley. This is why it's great that you guys are here today. Never been a better time to be an entrepreneur. All right, so back to the Lakers.
Back to the Lakers.
Back to the Lakers. So one of the things that we talk about in blitzscaling is the principle of winning a valuable winner-take-most market. In other words, when you get a hold of a particular asset that has a lasting competitive advantage where you can really monetize it, you should be willing to move on that. You should be willing to be more aggressive than anyone else to get a hold of that asset. And that's what's happened in the case of the sale of the Lakers. The Los Angeles Lakers are the premier franchise in the NBA. They have won almost as many championships as the Celtics, but those Celtics championships in the 60s shouldn't count because there were so few teams then. And the reason why the Lakers are so valuable is the combination of the tradition and history, plus the fact that they're in America's second largest media market, which is why, the only franchise that rivals the Lakers in value is the New York Knicks. So it's a crown jewel franchise. That's why Josh Kushner and Bob Iger wanted to buy it. And in fact, one of the buyers in their ownership group is going to be Thrive Eternal, which is Josh's fund for investing in assets where the holding period is going to be in decades. So if you think about from a Silicon Valley perspective, it's really a question of, when do I have the opportunity to get one of these crown jewel assets? In this case, it's a sports franchise. But in another case, it might be being the market leader in GPUs, or the market leader in social networking, or the market leader in smartphones, or so on and so forth. And the value of one of those franchises is so high that most people underestimate what you should be willing to pay. In the case of the Lakers, they just sold for $12.5 billion. Interestingly enough, the Celtics sold about a year ago for $6 billion. So take that, Celtics. But the other lesson here is something that comes out of the fan reaction by the Lakers fans. A lot of Lakers fans are unhappy about that, and that's not just because there's a vague sense that perhaps this is because of some sort of dark bargain with the White House, since Josh Kushner is Jared Kushner, the president's son-in-law's younger brother. And that's because the Lakers fans had gotten used to this idea of having Mark Walter, the previous owner, as the owner of the Lakers. He's also the owner of the Los Angeles Dodgers, who have been enormously successful and won 3 championships in the past 5 years or so. And Lakers fans were like, oh my God, I can't believe we're going from this guy who we think of as the best owner in sports because he has deep pockets and is willing to spend money, to these unknown guys. We don't know how they're going to do it. And my point was, well, actually, you have to look at the situation and not just be attached to the vision of what you thought something was, but understand what it is. The fact that Mark Walter was willing to sell the Lakers indicated that he wasn't, in fact, the deep-pocketed owner that people had idealized. And in fact, more has come out since then that, in fact, this entire time leading up to the sale, he was actually, and this was reported in the Financial Times, talking with Apollo about taking out a loan backed by his Lakers ownership stake to help him with his liquidity issues, as well as potentially getting an early buyout of the Lakers media deals or the Dodgers media deals to get him ready cash. So the point is, you have a vision of something and how it might work. Maybe it's your company, maybe it's a market. Things can change in an instant, and you have to be willing to take that new input and not cling to your vision of the past, no matter how attractive that vision was.
How important is it to do the background check on investors before they invest in your company, or how important or how influential can those investors on your cap table be to your company?
So it's incredibly important to check your investors before you take their money. So many people are familiar with the concept of checking references for their employees. Anyone here like hiring employees and saying, we don't need a reference check? Whatever they say, we just believe. No, nobody thinks that. But what I tell people is, you can fire your employees. You can't fire your investors. In fact, it's more important to reference check your investors than anyone else. And there's a very simple way to reference check them, especially now that we have things like Crunchbase and AngelList and all these ways to see what people have actually invested in. Let's go find the investments they made that failed and talk to those CEOs. It's very easy for people to be cool dude or nice lady when everything's going well. When everything goes to hell, all of a sudden you find out who was actually there, supportive, and who tried to run for the doors or grab some stuff on the way out. And so ask the CEOs and founders who failed among their investments. That's how you reference check those investors.
Going back to basketball, how important is it for founders and the team to play together just like players on the court?
Well, the main advantage you have as a startup founder is the fact that your team actually works together, right? As opposed to most large companies where it's a constant, endless turf war battle. I mean, a great example of this is Google. Literally, Google scientists developed the transformer architecture, wrote the attention is all you need article, and Google has somehow completely fumbled its ability to actually be a major player in AI. And that is because the people at Google would not play on the same team. All these different groups in this very decentralized structure would fight with each other for control of the compute, for control of the resources, for control of the budget. And as a result, the company that has more reason to be the AI leader than any other is now considered a sad also-ran. And so that can happen to one of the world's most powerful companies. OpenAI, Anthropic, these other startups defeated Google partially because of Google's own problems. Now, that's not to say that these companies don't have their own set of problems. Now that they're like 10,000 plus employees, I think another fun thing to do is to track OpenAI executive departure bingo, as we see the executives leaving, coming back, going back and forth. I mean, we haven't yet got to the point where there's somebody who's left twice and come back twice, but that's surely just a matter of time.
For basketball, your dream team, the 5 players all time, who would they be?
All right, so that is relatively straightforward. So you start with Magic Johnson, greatest point guard of all time, very key figure for leading the team. Then you add in, of course, Michael Jordan, who is the most maniacal competitor of all time. Many people consider him the greatest player of all time. I'm not entirely certain of that, but if he were in front of me, I would say, of course you're the greatest, Mr. Jordan, because I would be afraid of him. Then next, we would bring in LeBron James. LeBron James is the queen on the chessboard, able to do anything, able to do even more than what Magic was able to do. Magic could do a lot of things. Magic was never as good a shooter as LeBron. Magic was never as good a rebounder as LeBron. And LeBron, again, he has his downsides, specifically his abilities as a general manager have been terrible over the years. But we're just talking about on the court. Now, we've got those 3 as sort of core. Now we got to fill in around them. So first of all, what we need somebody who is a great center. We need a 5-man, if you will, to come in. And obviously there's a lot of great choices there. Bill Russell, Wilt Chamberlain, even Shaquille O'Neal. But I think in this case we're going to go with Kareem Abdul-Jabbar, who, of course, is overlooked many times these days, actually holds the record, the most NBA MVPs, won a national championship in high school, won 3 national championships in college, won 6 championships in the pros, and with the unstoppable skyhook. And that leaves us with 1 spot remaining, which we need to fill with somebody who's going to be a perimeter defender, somebody who is able to really play not point guard, but probably defend the point guards. Now, I did consider John Stockton of the Utah Jazz very underrated, but I think that we have a perfect choice here in this case. Even though he's not the greatest defender, I think he will open up the floor for everyone. We bring in Steph Curry.
Is that okay with the audience here?
Just imagine, again, you've got Magic, you've got Michael Jordan, you've got LeBron James, and you've got Steph. I mean, we were hoping to see Steph and LeBron playing together for an entire season. Didn't happen, but Steph has changed the game in a way that almost no other player has. We should get him as a guest next time as well.
I actually interviewed for the podcast Hussein from Unicorn founder, and Steph is LP in his company. So, but going back to the team itself, you didn't mention Dennis Rodman.
So the reason is Dennis Rodman is the most dominant player for his specific for the specific thing he could do, but he lacks the adaptability of these other players. Think about the players I just talked about with Magic, Michael, and LeBron. These are players who could do almost anything on the court. Dennis Rodman could do 2 things. He could rebound and he could defend. Also wear a wedding dress.
Yeah. Okay, so adaptability with basketball players, how does that relate or importance to being adaptable when growing a company?
Yeah, so one of the things you're looking for is that flexibility. And we see that in basketball, we see that in baseball, the other sport we've been talking about, where it's really important to be able to have players who can play multiple positions. And that's because what you need from any given match, any given game, any given project is going to change. And so especially early on, we talk about this in blitzscaling, you need to have generalists, people who have the ability to actually fill any role. And that is what happens during those early chaotic days. Now, as you get further along, as the company grows, maybe you have more specialists. Like classically speaking, we always talk about you bring in a specialist who is a globalization specialist, because that is a very specific thing that, of course, a smart person could learn how to do by asking ChatGPT or Claude, but better off to get someone who's actually done it.
Okay, that team that you put together, super competitive. I mean, Michael Jordan, most competitive person on the court.
He was those of you who saw Michael Jordan's Hall of Fame speech, he was still attacking the people he thought had disrespected him. He's Michael Jordan, greatest player of all time. He's going into the Hall of Fame, and he's like attacking his high school coach and players that he thought were beneath him.
So with that attacking everyone, are those people ever happy, and how important is happiness?
Excellent question. So the fascinating thing is you can look and see these different players and see different levels of happiness. Michael Jordan is what we call, in technical and scientific terms, a basketball sicko. And so all he wanted to do was win. Right? He would not. We've seen the examples from The Last Dance of him obsessively trying to win at everything, whether it is basketball, golf, or just rolling something down the hallway. He couldn't help himself. And I don't think it's a surprise that, ultimately he struggled to find something that was as compelling as that competition in his later life. He was not a particularly good general manager, not a particularly good owner in the NBA. In contrast, we have somebody like Magic Johnson, who has always been about competition for sure, but more about helping everyone else around him shine. And he has become one of the most successful post-career athletes ever in terms of the business world. He's a billionaire, not based on his basketball accomplishments, but on his business accomplishments. And every year, and he still hasn't invited me, I need to somehow get on this list. Every year he has a cruise in the Mediterranean with all his buddies. And so it's like some of his old friends from the Lakers, but also people like Samuel L. Jackson. I guess they were like great friends. Just imagine hanging out on a boat with like Magic Johnson and Samuel L. Jackson.
Oh, that'd be too much fun. So going to basketball, say you're on, say you get traded to a team or your team's not doing that good. How do you stay optimistic even with all the challenges that you might face for that season?
So this has happened to many people over the years who've been traded to the Sacramento Kings. Sorry, I saw some of my Sacramento friends in the audience, so I had to say it. The Sacramento Kings were great for a while during the early Maloof era. Some amazing teams there, but the fact is, when you are traded to a team, there's only so much you can control. And by the way, you may find yourself in this situation as a founder, right? You've taken money from investors, now the market changes, and you're going to do your best to make things work out, but it's going to be a lot harder. And so this is where I feel like there are two separate things you really need to do. The first is you need to concentrate on the craft, right? The rewards of the work itself, getting better, building new skills, and so on and so forth. And the second is to have a happy life outside of your work or off the court. Because if you only care about what's happening on the court, you're a total sicko. It's like Michael Jordan playing for the Washington Wizards, missing the playoffs twice. Not only was he struggling on the court, but he was struggling off the court. He's like, what did I do? I gave up my ownership position in the Wizards. And by the way, they never gave it back to him. So it cost him a huge amount of money too. Or Tom Brady deciding to get divorced so he could play an extra season and miss the playoffs. What is up with that?
Not sure if that was his decision, but
No, it was. Look, she told him she wanted him to stop. He said, no, I'm going to go back and play again. And she said, fine, I will then have an affair with my Brazilian physical trainer.
Alex Dantes.
Yeah, exactly. Not even sure where to go with that one.
I hope you could release this someday. I don't know if you'll be able to.
It's live streamed right now.
Oh, wonderful.
So going with that, okay, so on the court, on the field, these athletes, they're focused 100%. Founders the same. Maybe the moment they're awake or if they even sleep are focused on that business. How do they transition out of that role into retirement or after the sale of the company?
So this is one of the hardest things that so many athletes struggle with, so many entrepreneurs struggle with. And I know, for example, Anu and I heard a speaker who was talking about his life after this incredible accomplishment. He sold his company, he had all this money, and he was kind of lost. It took him a while to find that meaning and purpose because for however many years, the goal was just, I'm going to make this company successful and I'm going to make a huge pile of money. And then all of a sudden it's like, now what? So what I would encourage people to do is, first of all, don't defer all the things in life that make you happy until after that success, because you never know when that success is going to come. So you got to carve out time for the stuff that really matters to you. Again, what matters to you is going to be different for every person. Some people are like, oh, my family is the most important thing. And other people are like, screw my family. I never want to see them again. Like, there's nothing wrong with either of those positions as long as you understand for yourself what actually makes you happy. And then the second thing is you have to all along, whether you're an athlete, whether you're a founder, you have to keep reminding yourself, my career is not who I am. My company is not who I am. Right? I have a separate identity from all of those things. Yes, my identity in the world, my fame, my fortune may come from those things, but that's not who I am. And hopefully there are people in your life, and this is one of the reasons why it's very important as a founder to maintain relationships with people that you knew long before you were a founder, and especially long before you somehow became mega rich, which is you need people who you know actually want to be with you for you.
You mentioned this a little bit in our first conversation, but the importance of being aware of trends and that. One, once again, to go back, the importance of that, why, and then also what trends are you seeing, walking the floor here at this event, conversations you're having?
So the reason why you have to be aware of trends is not because, we have to be trendy. It's because those trends are how the world is changing. And so it's very easy, and I remember, earlier in my life, having friends who were my age or even older who their minds were closed to new things. Like I always say, somehow miraculously most people seem to think that all the best music was created before they turned 25. I don't know why that is. And so as a result, being open to these trends, studying trends, allows you to break out of your natural conservative instinct to say, I learned everything I needed to by the age of 25. But the other element of being on top of trends is if you are able to understand these trends and be able to apply the kind of pattern recognition, resources, skills you've already developed. Like a person who is later on in their career who's able to identify these new trends, those are the people who really do incredibly well. And oftentimes they can do that as investors, but they could do that as founders as well. Because you've built the skills, you've built the relationships, and you have the ability to actually adopt these new technologies, these new approaches.
Going back to the whole basketball team, how important is it to trade players on a team to get to that end goal? How important is it for a company to trade players to get to the end goal?
Yeah, I think that this is really important. And of course, there's a book that we wrote that came out in 2014 called The Alliance. It's by my friends Reid Hoffman and Ben Kesnoka and myself. And we talk about how companies are like professional sports teams. They're not like families. There comes a time when you may have to trade that player for someone else for whatever reason. So a great example, let's take the Lakers. The Lakers in the late 1990s had a player named Eddie Jones who was very popular with the fans, actually an all-star shooting guard. And the Lakers traded him. Why? Because they had this other player named Kobe Bryant who was coming up. And they could never actually properly utilize the team with these overlapping skill sets. They needed to choose. They needed to pick the player who was going to ultimately be better, and they needed to go ahead and turn that player into some other resource. And he ended up being traded for Glenn Rice, who helped them win one championship. Glenn Rice was traded for Horace Grant, who helped them win one more championship after that.
All right, we do have a couple minutes left. Let's open it up to the audience for one or two questions.
And they don't have to be basketball related, although that is a bonus.
They definitely should be basketball related. And then afterwards, it's presuming barbecue time. Okay, we got a hand up back there. Can you yell it loud enough for everyone?
What do you think of legal tech and the boom in these valuations? And there's so many, it's a crowded space. You have ChatGPT and Claude and all that stuff.
Can you repeat the question?
Yeah, so the question is, what do you think about legal tech and the boom of valuations, et cetera? So I have a generally negative view of this. I apologize to all the legal tech investors and founders in the audience. So I think that it is possible to succeed in this space, but the fact is that we are going to have a shrinking legal market. The reason is that the demand curve for legal services is inelastic. So as the price of legal services goes down, we don't have like 10 times as many lawsuits, or at least I hope not. And so as a result, there is value in being a legal tech startup, because what you can do is you can be the one that is the grim reaper for the current legal system, and you can make money that way, but the overall system is going to shrink. And so I do think that I have some concerns about the really high valuations on legal tech, because they're like, oh, we're going to take over the whole legal industry, and therefore we can take that multiple and attribute it to our software company instead. I'm like, no, take that multiple, cut it in 10, and then attribute that to your company, because that's where we're going to eventually head. We're going to have plenty of legal services being consumed, but we're going to have 1/10 the number of lawyers.
One more question?
See?
Yes.
So with all out there and the fact that you could do more with less, what does that mean for founders and VCs and when they approach VCs?
Yeah. So first of all, it allows founders to do a lot more before they raise money, which is awesome for both the founders and the VCs. It's awesome for the founders because you get to maintain your flexibility. You get to actually find out whether your product's going to work or not before you raise money from people, which means you're stuck. Like once you raise money, you're stuck. My first company, I raised money for it. I was stuck running it, even when I didn't want to run it anymore, which was unfortunate, but I did the responsible thing and kept running it and got as much money from my investors as I could. The second thing, and there's this sort of implied question that people wonder about, is what's going to happen to the VC industry, right? What's going to happen when agents can go out and assess, who's hiring on LinkedIn, or how many GitHub stars do people have, and so on and so forth. And I'm like, yeah, you know what? I think that those functionalities are probably going to be taken over more and more by AI. But it fits into the category of, I think that there's still going to be a need for venture capital because there are still many businesses that are going to require humans as well as AI, and by the way, AI ain't cheap either. And what hopefully will happen is that venture capitalists will start using AI to do the actual analysis, so they're not just guessing, which most of the time they are. When they say they're pattern matching, that's just another way of saying we're guessing, but we make it sound cooler. And so that they can actually focus on developing a relationship with the founders out there to figure out, is there a fit? Because like I said, you can't fire your investors. Well, if you only get to know your investors through them firing questions and you answering them, well, what's the point of that, right? That's something that the AI should be doing. What you should be doing instead is deeply understanding, okay, is this somebody I can work with for the next 10 years?
All right, let's have one more question. Okay.
For like middle-class people, how can they participate in the data center boom? And is there extreme risk? Because will there be losers in that space?
So in terms of the data center boom, I think that it is entirely possible that the CapEx level will prove to be unsustainable because there's just so much money being spent. That being said, the benefit is those data centers get built, they're going to be used at some point in time. So it's not like that investment is going to go to waste, but it may be something that people have some regrets about, like people who are plunging money into data centers right now. Why are they doing it? Because they're like, this is safe. There's no way this could fail. I'm like, the instant everyone thinks something is safe and there's no way it could fail, that is the time you should be really scared. How people should play this, I think ultimately the best way for people to do most things in life when it comes to finances is to invest in a broadly diversified portfolio, possibly through mutual funds or ETFs or whatever. And for God's sakes, try to avoid looking at stock prices as much as possible.
No investment advice here.
No investment advice here. I'm not a registered investment advisor.
All right. And let's give Chris a round of applause.
Thank you, Sean.
All right. And let's bring up Shermy from Circuit Launch. Shermy.
Oh my gosh.
You good words.
Okay. I guess I've been given the fun job of actually announcing when food is going to be ready. So I'm appreciative. I just want to give a quick round of applause for all of you guys. I've seen some of you that's been here all day. Thank you for sitting through and thank you for being here. Woo! Okay. And then also, we've rounded up a good amount of speakers together, and everybody kind of came over here on a Wednesday afternoon. You could be anywhere else in the world in the Bay Area right now, but you're here. We're appreciative to all the speakers that did show up today. A huge thank you to Ken, to Sean, to Sonia, all the volunteers for putting this event together. I mean, like, this is incredible. I mean, we only started talking about this a month ago. I feel like this is miracles work. So round of applause for everybody that's been here for that. If you see my team out there from the Circuit Launch team, everybody's been working very hard all day today, getting the food ready for you guys, and also kind of preparing for this event. So if you do see them, please give them a thumbs up, a kudos, anything, appreciate them. Lastly, so we have a little bit more programming to do for the rest of the evening, but they're really fun, I promise. We are going to be doing a quick interaction and a showcase with AGI Bot right in front. They can answer questions, they can do dances, all that. Anything you've seen on the news about their robots, they can do it here, so you can see it live. After that, we are going to kick off the musical performances with Snow. So she's going to be doing a performance with her cyber band. So she's actually going to be electronics music along with robot arms. So very fitting to tonight's theme. And then after that, food will be served. So it's going to be amazing, like Brazilian barbecue. And there are sides. If you see Alex out there slaving away, he's the one that's serving the food and cooking the food for us. Again, thank you guys for being here. This has been awesome. So thank you guys for putting everything together.
A few more thank yous for everyone. We want to thank Orbis 86. Let's give a round of applause. Woo! All right. Students that put all the time and effort into this. Jean Marie, Citizen Bank, we want to thank you for sponsoring. Stand up, wave. Let's give a round of applause. Woo! Also remember the growth awards are coming up. So if you have a company you'd like to nominate, So we have to thank them. Hopefully everyone took advantage of the truck and driving around. And have to thank Circuit Launch. Let's give a round of applause for Circuit Launch. And let's get a round of applause for Ken. Please stand up, Ken.
And I have the glory of course, there's a lot of drinks. Make sure you grab some. We don't want to take it back, right? Or else we'll just use it for the next one. There's the Coors Light special. Our Swiss students know
Be
what
responsible.
that means. Just drink some Coors Light. But I always like saying, wrapping up, is the greatest gratitude is you all, the community, for showing up, be here, right? Listen, I saw some of the folks like listening to each of the panel. Really appreciate that, and each one of you engaging with the speakers, and of course, speakers like Chris, who could be anywhere, but they chose to be here to share their knowledge and experience. So thank you, Chris, and I'll hand it back to Sean for some more closing.
That is it. All right, round of applause one more time for everyone. Round of applause for Circuit Launch. Round of applause for our speakers.
So AGI bots, so they should follow you. We're gonna go outside.
All right, stand up, everyone.
All right, get some stretch. Thank you.
Yeah. Chris, thank you.
Gents, thank you so much.
You get a quick photo. Oh, you got a photo last time.